Hello there, and welcome to Life Beyond Seen, where curiosity moves slowly, strange stories are handled gently, and the world becomes a little wider just before sleep. Tonight, we are heading far from busy roads, glowing windows, crowded rooms, and all the ordinary little sounds that follow us through the day. We're going beneath the surface of the Caribbean Sea, down past the bright water where sunlight still flickers, down past the coral reefs and the drifting fish, down into darker water where machines have to do the looking for us, because human eyes cannot easily visit there. And waiting in that deep place, off the western edge of Cuba, is one of the strangest modern ocean mysteries ever reported. Not a confirmed lost city. Not a proven ancient civilization. Not something we can honestly point to and say, yes, there it is, case closed. But something unusual, something recorded by sonar. Something that looked, at least to some of the people who first saw it, a little too organised to ignore. This is the story of the Cuban underwater formations, often called the underwater city beneath Cuba. And even that name needs to be held carefully, like a cup of tea that is still a little too hot. Because city is a very strong word. A city has streets, walls, buildings, doorways, people, routines, arguments over breakfast, someone being late, someone sweeping a floor, someone wondering where they left a tool. A city is not just stone. It is life arranged into pattern. What was reported beneath the water near Cuba may not be a city at all. It may be geology. It may be an illusion of sonar. It may be natural rock shaped by forces that work slowly and without asking our permission. But it was strange enough to catch attention, and quiet enough afterward to leave the question floating there for decades. So tonight, we're not going to shout about Atlantis. We're not going to declare that history has been rewritten while everyone else was busy making sandwiches. We're going to move carefully. We're going to look at what was claimed, what was seen, what scientists questioned, what the ocean makes difficult, and why some mysteries stay alive not because they have been solved, but because they have not been looked at closely enough. That can be a little frustrating, of course. Humans do like answers. We like labels, dates, maps, neat explanations, and preferably a small sign that says, mystery solved, gift shop to the left. But the sea does not work that way. The sea is very good at making things hard to reach, hard to photograph, hard to sample, and hard to understand. It covers things with darkness, pressure, sediment and time, which is rather rude of it when one is trying to make a tidy documentary. Before we sink any deeper into this story, let me ask you something simple. Where are you listening from tonight? Are you somewhere near the ocean, where the air sometimes smells faintly of salt? Or are you far inland, where the sea feels more like an idea than a place? And if you're settling down to sleep, is your room quiet? Or is there some small sound nearby? A fan, distant traffic, a sleepy pet, a refrigerator making that strange little midnight hum as if it has just remembered a secret? It is a fitting question for a story like this, because the mystery beneath Cuba is also about distance. Distance from shore, distance from certainty, distance from the time when the first strange shapes appeared on a screen and people began wondering what exactly they were looking at. If you find this kind of slow journey soothing, and if you enjoy calm stories about science, archaeology, oceans, lost places, and the odd corners of the world that still make us pause for a moment, I would be grateful if you liked the video and subscribed. It helps this quiet little space reach other curious night travellers, the ones who enjoy learning something unusual while the day softens around them. And if you're already tucked in, with one hand half outside the blanket, because that is apparently the correct sleeping temperature for human civilization, then there is no need to do anything quickly. Nothing about tonight's story is in a hurry. The formations have been waiting beneath the water for a very long time, whether they are natural stone, misunderstood shadows, or something far stranger. Picture Cuba from above for a moment, not in a dramatic way, just as it really is on a map, a long island stretching between the Gulf of Mexico, the Caribbean Sea, and the Atlantic. Its western end tapers toward the Guanahaca-Bibis Peninsula, a remote stretch of land in Pinar del Rio Province. The area is known for reefs, coastal ecosystems, and a kind of edge-of-the-map feeling, where land gives way to open water and the Yucatan Channel lies beyond. It is not the image many people first have of Cuba. It is not Havana with old cars and bright buildings. It is not music spilling from doorways. It is quieter than that, more open, more exposed, a place of coast, reefs, limestone, birds, storms, and deep water nearby. And somewhere off that western region, in the early 2000s, sonar equipment picked up forms on the seabed that did not look ordinary to the people watching the screens. Sonar is a useful tool, but it is not a magic window. It does not simply show the ocean floor as if someone switched on a lamp. It sends sound into the water and measures how that sound returns. From those returns, it builds an image. That image can reveal shapes, slopes, hard surfaces, soft sediments, ridges, blocks, and patterns. But it can also mislead. A shadow on a sonar image can look like an edge. A natural ridge can look like a wall. A broken rock field can look, from a distance, like a set of arranged stones. Anyone who has stared at clouds and seen a rabbit, a ship, or the face of someone they once met in a supermarket knows that the human brain is very eager to find pattern. The brain means well. It is trying to help. It is just sometimes a little too enthusiastic, like a dog bringing you a shoe you didn't ask for. That is part of what makes the Cuban formation so interesting. The reported shapes were not found in shallow water where divers could easily swim down, brush away sand, take measurements, collect samples, and return with clear photographs. They were reported at roughly 600 to 750 meters beneath the surface. That is deep enough to turn every question into a project. At that depth, ordinary scuba diving is out of the question. Sunlight is gone, pressure is intense. Exploration needs special equipment, remotely operated vehicles, strong cables, careful planning, funding, ship time, and patient people who know how to work in a place that is not friendly to mistakes. It is one thing to wonder about a mystery from a comfortable chair. It is another thing to send machines into deep water and ask them to bring back answers, while the ocean quietly tries to keep everything for itself. The first reports described geometric shapes, smooth blocks, and forms that some interpreted as pyramids or circular structures. Now those words are very powerful. The moment someone says pyramid, the imagination puts on a hat and runs out the door. We start thinking of Egypt, temples, lost cultures, secret knowledge, old maps, and probably a dramatic narrator whispering over thunder. But a pyramid-like shape in geology does not automatically mean a pyramid made by people. Nature can make angles. Nature can fracture stone. Nature can stack, split, fold, erode, and arrange rock in ways that look surprisingly organised. Basalt columns can form regular patterns. Limestone can dissolve into strange terraces and blocks. Tectonic movement can break the seabed along lines. Sediment can hide one part of a formation and reveal another, making something look more intentional than it is. Nature does not need a ruler to produce straight edges now and then, though admittedly when it does, it makes archaeologists and documentary writers sit forward in their chairs. And still, we should not swing too far the other way either. Skepticism does not mean boredom. It does not mean shrugging and saying, probably rocks, before going to make toast. Good skepticism is not the enemy of wonder. It is how wonder stays honest. A strange sonar image deserves interest. A possible formation deserves more study. A claim of an ancient underwater city deserves careful testing. The difference between those things matters. It is perfectly reasonable to say, that is unusual. It is much less reasonable to say, therefore an unknown civilization built it and the history books are finished. The truth, when we have it, usually arrives more slowly. It arrives with samples, measurements, repeated surveys, better images, independent analysis, and the slightly less glamorous work of comparing one rock to another rock until everyone involved needs a quiet cup of coffee. One reason the city idea becomes difficult is the depth. During the last ice age, when much of Earth's water was locked in ice sheets, global sea level was lower than it is today. That is why many real archaeological sites are now underwater in different parts of the world. Coastlines moved. People lived near shores that later flooded. Rivers, camps, tools and settlements were swallowed as the sea rose. That part is not strange at all. Underwater archaeology is full of real submerged landscapes, but the amount of sea level change matters. If sea level was around 125 metres lower at the last glacial maximum, that helps explain many shallow submerged sites. It does not easily explain something 600 metres down. For a human-made city to end up that deep, you would need more than ordinary post-ice age sea level rise. You would need major geological movement, sinking land, some complex local process, or a much older scenario that runs into other problems, especially when we compare it with what is known about human societies in the Americas at those times. That is where the story becomes less like a simple treasure hunt and more like a careful puzzle. If the formations are natural, what process made them look so regular? If they are not natural, how could they be so deep? If they are partly natural and partly misread by sonar, what did the original images actually show? If there were later video surveys, how clear were they? Were samples collected? Were they examined? Are the original data available for independent researchers? These are not as flashy as saying Lost City, but they are the questions that matter. They are also very good questions to fall asleep to, because they do not demand that you solve them tonight. You're allowed to let the mystery remain unfinished. The ocean has been doing that for ages. There is also something quietly human about the way this story spread. A research team sees unusual shapes. A phrase like urban complex appears in early reporting. News outlets pick it up. People read it over breakfast. Someone thinks of Atlantis. Someone else thinks of the Maya. Someone else thinks of ancient maps, lost continents and hidden history. Before long, the careful phrase could be has put on a dramatic coat and become is. This happens often with archaeology and ocean mysteries. A cautious observation grows into a confident claim as it travels from article to article, video to video, conversation to conversation. The mystery becomes heavier with every retelling, like a suitcase packed by someone who refuses to choose between shoes. By the time it reaches us years later, we have to unpack it gently and see what was actually inside. The Cuban underwater formations are especially suited to that kind of retelling because they sit at the crossroads of many things people already find fascinating. They are underwater. They are near the Caribbean. They are described as geometric. They were reported at great depth. They have not become a neatly resolved public scientific case. They invite comparisons to Atlantis, even when those comparisons may not help. They make people wonder whether the ancient world was more complicated than we know. And perhaps most importantly, they leave enough blank space for imagination to move around. A fully solved mystery becomes information. An unsolved one becomes a room with the lights low, where every shape might be furniture or might be something else entirely. But tonight, we will keep our feet, or perhaps our flippers, on the ground. We can enjoy the strange feeling of the story without pretending the evidence is stronger than it is. We can picture the sonar screen without turning every shadow into a temple. We can think about real submerged coastlines, real sea level rise, real geology, and real deep sea exploration. We can also admit that the world has surprised us before. Ancient sites have been found where people did not expect them. Landscapes now underwater were once dry land. Human history is not complete. New discoveries do happen. The careful position is not to say impossible, it is to say unproven. And unproven is not a dull word. Unproven is a doorway that has not been opened yet. So settle in a little more, let your shoulders drop, let the room around you become less important for a while. Imagine the sea west of Cuba after sunset, the surface darkening, the last warm colour leaving the sky, and below it all, far beneath the waves, a patch of seabed that once made people stop and stare at their instruments. Whether those shapes were stone blocks, natural ridges, sonar shadows, or something that deserves another serious expedition, they remind us that the planet still contains places where certainty has not arrived. And maybe that is why the story keeps returning. Not because it gives us an answer, but because it gives us a reason to look more carefully. The first step is to return to the moment of discovery, not as legend, but as a working survey on the water, with equipment humming, screens glowing, and the seafloor slowly revealing shapes that no one on board was expecting. The survey did not begin as a search for a lost city. That is one of the quieter details that makes the story feel more believable, and also more complicated. The people involved were not sailing around the Caribbean with a map covered in red ink, hoping to uncover Atlantis before lunch. They were using sonar to examine the seafloor, partly in connection with shipwreck exploration. That is already interesting enough, because the waters around Cuba have a long history of ships passing through, ships getting caught in storms, ships being chased, ships sinking, and ships leaving behind the kinds of objects that make marine explorers very patient people. Coins, anchors, cannons, cargo, broken hulls, and all the remains of journeys that did not end as planned. The seafloor around old sea routes is not empty. It is more like a very large, very dark attic, except the attic is under hundreds of meters of water and does not come with a ladder. The equipment sent sound down into the sea. That sound moved through the water, struck the seabed, and returned as signals that could be turned into images. Not photographs exactly. More like a shadow map made from echoes. Sonar is extremely useful, but it asks the viewer to interpret what it gives back. A hard surface may return a strong signal. A soft seabed may return a weaker one. A slope may cast a kind of acoustic shadow. A ridge may appear as a long line. A boulder field may become a pattern. A pattern may begin to look like structure. And once the human mind notices structure, it becomes very hard not to keep seeing it. This is not because people are foolish. It is because the brain is built to detect order. That ability helped our ancestors notice tracks, faces, movement, danger, food, weather, and possibly the one person in the village who had borrowed a tool and not returned it. So imagine the moment on the vessel when the first unusual forms appeared on the sonar display. There would have been the ordinary working atmosphere of a survey, the steady routines of equipment, coordinates, depth readings, people watching screens, people checking instruments, someone probably drinking coffee that had been warm half an hour earlier. Then the seabed began to show something that looked less like random terrain and more like a set of arranged shapes. Not one strange rock, not one ridge, a wider field of forms. The reports that later spread described smooth blocks, crests, geometric shapes, pyramid-like structures, and circular arrangements. Some accounts spoke of stones that appeared stacked. Others described the site as having the look of an urban complex. Those words travelled far, because they are the kind of words that do not sit quietly in a sentence. Once people hear pyramid and underwater and Cuba in the same story, the imagination starts unpacking its suitcase. But before imagination gets too comfortable, it helps to picture what the sonar image really means. A sonar screen does not say, "Here is a building." It gives shape, height, texture, shadow, and reflection. The interpretation comes afterward. If the seafloor contains hard rock protruding from sediment, sonar may show it sharply. If the rock has fractured along straight lines, the image may look rectangular. If erosion has carved channels between raised surfaces, those channels may look like roads. If blocks have tumbled down a slope, they may appear stacked. If sediment partly buries some features and leaves others exposed, the visible pieces may look deliberately placed, even when they are not. The ocean floor can be full of forms that look meaningful from a distance, and distance is one of the main characters in this story. At roughly 600 to 750 meters below the surface, the site is not in the bright, familiar underwater world of vacation diving. It is not a place where sunlight falls on coral and a diver can point at something, swim closer and say, "Well, that is definitely a stone block," or "No, that is clearly a natural ledge." It is deep enough that every observation depends on equipment. There is no casual inspection, no easy return visit, no quick sample taken by hand. This is a place where technology becomes the eyes, and technology, however impressive, still leaves room for doubt. The strange shapes were not sitting in a museum case. They were sitting under dark water, inside pressure, distance, and imperfect data. And yet, what the team believed they were seeing was not easy to dismiss. Reports described a field of shapes spread across a large area. The forms seemed to have repetition. Some appeared angular, some appeared rounded. Some had the kind of outline that can make a viewer think of plazas, walls, terraces, or foundations. One might imagine a set of enormous stones resting on the seabed, silent and cold with dark water moving slowly over them. Of course, that image may be more dramatic than the data allows, but it is also not hard to understand why the first viewers felt a jolt of excitement. Most days, when people scan the seafloor, they expect geology, sediment, wreckage, or the usual clutter of the ocean bottom. They do not expect a pattern that makes someone in the room say, very carefully, "That looks organised." The phrase "looks organised" is both the beginning of the mystery and the beginning of the problem. Many things look organised. Cracked mud looks organised. Honeycombs look organised. Basalt columns look organised. Salt flats can form repeating polygons. Limestone pavements can break into slabs divided by straight grooves. Crystal growth can produce symmetry. Erosion can carve steps. Earthquakes and landslides can move huge blocks into arrangements that seem almost built. Nature is not random in the simple way we sometimes imagine. It follows rules. Pressure, chemistry, gravity, heat, cooling, uplift, faulting, dissolution, and erosion can all create forms that repeat. Nature can be messy, but it can also be very neat when it feels like showing off. This is why underwater archaeology has to be so careful. A true human-made site usually leaves more than shape alone. It may leave tool marks, consistent measurements, worked surfaces, pottery, bones, hearths, carved objects, construction patterns, or materials that are clearly out of place. On land, archaeologists can dig, map, measure, brush, photograph, and compare. Underwater, especially in deep water, the work becomes much harder. Shape is only a clue, it is not a verdict. A blocky seafloor may invite questions, but it does not answer them by itself. The Cuban formations sit in that uncomfortable middle space, interesting enough to talk about, not proven enough to name with confidence. There is something almost funny about how quickly the human mind moves from unusual sonar return to lost civilization. Not funny in a mocking way, more like funny in the way humans always reveal themselves. We are story-making creatures. Give us a line and we look for a road. Give us a circle and we think of a plaza. Give us a triangle and suddenly someone is mentioning pyramids, ancient knowledge, and perhaps a dramatic flute in the background. The mind does not like loose pieces. It wants them connected. It wants the seabed to become a map, the blocks to become buildings, the shadows to become streets, the mystery to become history. This is a beautiful instinct in art and storytelling. In science, it needs a chaperone. Still, the reported shapes did have a powerful pull. The idea that something resembling a city might lie beneath the Caribbean has a special kind of atmosphere. Cuba itself sits in a region filled with histories layered over histories. Indigenous cultures lived there long before European arrival. Later came Spanish ships, colonial routes, fortifications, piracy, trade, conflict, migration, and all the restless movement of the Caribbean world. The sea around the island has carried canoes, galleons, warships, fishing boats, merchant vessels, and modern research craft. So when an unexplained formation is found offshore, it naturally drifts into a much larger human story. We imagine old coastlines, drowned lands, forgotten people, and a world before the maps we know. But the depth keeps interrupting the dream. That is the stubborn fact that cannot be gently moved aside. Many submerged archaeological sites around the world are in relatively shallow water because sea levels rose after the last ice age. People often live near coasts, rivers, estuaries, and rich marine environments. As ice melted and seas rose, some of those landscapes were covered. This is a real and important part of archaeology. The sea has hidden old human places before, but hundreds of meters is a different matter, a sight that deep cannot be explained by ordinary post-ice age sea level rise alone. The reported Cuban formations are not a village just below the waves. They are in deep water, far below the amount by which sea level changed after the last glacial maximum. That means any human-made explanation has to carry a very heavy load. Some early comments suggested that the structures might be thousands of years old. That kind of claim makes headlines, but it creates more questions than it solves. If the formations were once on dry land, then when were they dry? If they sank, how quickly did that happen? What kind of geological event could move such an area to such a depth? Would the structures remain so clear after that movement? If the site were extremely ancient, what kind of people could have built it? Does that fit with what is known from archaeology in the Americas? These questions are not meant to close the story. They are meant to keep it from floating away. A good mystery needs weight, or it becomes just another balloon lost in the sky. The reported shapes themselves are also difficult to evaluate, because most people have only seen interpretations or descriptions, not a full scientific archive of the raw data. That matters. In serious research, independent experts need access to data. They need to know the sonar settings, the resolution, the survey path, the angle, the processing methods, the location, the bathymetry, the geology, and the context. A single compelling image can be persuasive to the public, but a full data set is what allows scientists to test whether something is truly artificial or simply appears that way. Without enough open data, the story remains suspended between claim and confirmation. It becomes famous but not settled. That is a strange kind of fame. The site is known enough to inspire videos, articles and speculation, but not known enough to be securely understood. If you have ever looked at satellite images of deserts, mountains or ocean floors, you may have noticed how easily the eye turns natural patterns into designs. A ridge becomes a wall, a dry stream bed becomes a road, a group of rocks becomes ruins. Archaeologists who use remote sensing deal with this all the time. Sometimes the pattern really is human-made, sometimes it is not. The difference is established by follow-up work. You go to the site if possible. You collect samples, you check the material, you examine the setting, you compare it with known natural formations, you look for cultural remains. You try very hard not to fall in love with your first interpretation, because first interpretations are charming, but not always trustworthy. They are like first drafts, useful, exciting, and often in need of a stern editor. In the Cuban case, there were reports of later attempts to look more closely, including video from a remotely operated vehicle. Some descriptions claimed that large smooth blocks were seen, but again, the public evidence has remained limited. A remote camera in deep water can provide valuable views, but visibility, lighting, angle, scale and distance all matter. A rock can look cut from one angle and natural from another. A large block can seem placed until you see the slope it fell from. A smooth surface may be a worked face, or it may be a fracture plane. Without careful sampling and mapping, certainty remains out of reach. The ocean is very good at giving half answers. It shows enough to keep you interested and hides enough to keep you humble. There is also the question of what kinds of rocks might be there. Some popular accounts have mentioned granite-like blocks. which sounds impressive because granite is associated with massive monuments in many places. But saying something looks like granite on video is not the same as proving its composition. Rock identification underwater from images alone can be unreliable. A pale limestone surface, a weathered block, or a crusted formation might look different depending on lighting and sediment. To know what the stone is, researchers would need samples analysed in a lab. If the rock were truly unusual for the area, that would be interesting. If it were local geology, that would point in another direction. Either result would be valuable, but without that level of evidence, granite-like remains a description, not a conclusion. The most grounded view is that the sonar showed unusual formations that deserved more study. That may sound modest, but it is a strong statement. It does not throw the mystery away. It does not inflate it either. It leaves the door open while refusing to decorate the room before we know what is inside. The shapes beneath the waves could be natural rock structures, perhaps fractured, eroded or displaced in ways that produce regular-looking forms. They could be sonar artifacts made more dramatic by processing and interpretation. They could be a mixture of real geology and human pattern-seeking. Or, less likely but more exciting, they could include something genuinely artificial that has not yet been properly documented. The honest answer is that we do not yet have enough publicly available evidence to say, and perhaps that uncertainty is why the story has lasted. A clearly natural formation would have faded into a geology report. A confirmed ancient city would have transformed archaeology. But something in between becomes a long-lived mystery. It returns every few years, especially when someone rediscovers the old reports and asks why no one is talking about it. The answer is not one simple thing. Deep-sea research is expensive. International permits can be difficult. Ship time is limited. Scientific priorities compete for funding. Political and logistical issues can slow everything down. And if the first evidence is intriguing but not conclusive, it may be hard to convince institutions to spend large amounts of money on a return expedition. Mystery is cheap to discuss, but expensive to investigate. This is deeply inconvenient and also very typical. So when we imagine those strange shapes beneath the waves, it may be best to imagine them without deciding too quickly what they are. Picture a dark seafloor west of Cuba, a region of hard forms rising from sediment, captured in sound rather than sunlight. Some edges appear straight, some shapes seem repeated, some forms are large enough to suggest blocks. The instruments trace them, the data builds a picture, and somewhere above on a vessel moving over deep water, people stare at the display and feel that rare surveyor's feeling that the ordinary day has just changed. Not because the answer has arrived, but because a question has. That question is still down there. It rests with the formations themselves, whatever they may be. If they are natural, they still tell a story about the forces that shape the seabed. If they are a sonar illusion, they tell a story about the limits of remote sensing and the eagerness of the human mind. If they are something more, then they wait for the kind of evidence that can survive daylight, peer review, and a very skeptical geologist with a pencil. For now, the shapes remain strange, and strangeness is not a small thing. It is often where investigation begins. The deeper we go into this case, the more one fact begins to press on every explanation. The formations were not reported just below the surface, not near a beach, not in the comfortable shallows where lost harbours and drowned settlements are usually found. They were described far below, in a zone where pressure rises, light disappears, and every simple question becomes difficult to test. And that depth is where the mystery starts to become harder, slower, and much less willing to give up its secrets. The problem with this discovery is not only what was seen, it is where it was seen. If the same shapes had been found in 10 meters of water, close to the coast, the story would still be interesting, but it would be easier to approach. Divers could swim down, archaeologists could place measuring tapes across the seabed, cameras could take clear photographs in daylight, Samples could be brought up by hand. A team could return again and again, each time learning a little more. Shallow water has its own difficulties, of course. Waves, currents, sand, storms, and curious fish with no respect for careful excavation can all be troublesome. But shallow water at least allows people to visit. It allows direct work. It allows the mystery to be touched. The Cuban formations were reported much deeper than that. They were not resting just below a reef, or near the kind of drowned shoreline where ancient camps and settlements are sometimes found. They were described hundreds of meters down, in a zone where ordinary human exploration stops and machines must take over. That depth changes everything. It changes the cost, it changes the risk, it changes the type of evidence that can be collected, it changes the number of people and institutions able to investigate. It even changes the way the public understands the story, because deep water has a strange effect on the imagination. The deeper something is, the easier it becomes for us to fill the distance with possibility. 600 meters of water is not just a number, it is a physical barrier. At that depth, pressure is immense. Every square centimetre of a surface is being pressed by the weight of the water above it. Light from the sun has long since faded. The colours that make tropical seas look inviting near the surface are gone. The bright Caribbean becomes a dark working environment, visited by specialised equipment and adapted creatures, not by casual swimmers. A human body cannot simply go there with a tank on its back and a sense of adventure. That would be less exploration, and more a very poor decision made without enough sandwiches. So the first difficulty is access. To examine a site at that depth, researchers need a ship capable of supporting deep-sea work. They need sonar systems, remotely operated vehicles or submersibles. They need cameras that can function in darkness, light strong enough to show the seabed, navigation systems precise enough to return to the same spot, mechanical arms if they want to collect samples, and people trained to operate everything safely. A short look at the bottom may require long preparation at the surface. The ocean may look calm from above, but deep-sea work is never casual. It is not a person leaning over the side of a boat with a flashlight saying, "Yes, I think I can see something." It is cables, winches, control rooms, weather windows, permissions, fuel, maps, specialists, and a budget that tends to grow in a slightly alarming way. This is one reason the story did not quickly become a clear scientific case. The public often hears about a strange discovery and expects the next step to happen almost immediately. A mystery is reported on Monday, a team investigates on Tuesday, and by Thursday everyone knows whether it is a lost city, a rock formation, or someone's misplaced patio furniture. Real exploration is much slower, especially in deep water. A ship has to be available, funding has to be secured, governments may need to approve work in their waters, equipment has to be booked, scientists need a reason strong enough to justify the cost. And if the first evidence is intriguing but not conclusive, that can be an awkward place to begin. It is too interesting to ignore, but not solid enough to guarantee support. Many mysteries live in that gap, looking slightly embarrassed, holding a folder of partial evidence. Then there is the second difficulty, which is interpretation. At great depth, most of the first information comes through remote sensing. Sonar gives shape, but not always certainty. A sonar image may show forms that look rectangular, circular, stepped or aligned. But whether those forms are walls, fractured bedrock, scattered blocks, sediment ridges, or acoustic shadows is another matter. The image is a clue, not a final answer. And at a deep site, every clue has to travel through equipment before it reaches us. Sound goes down, signals come back, computers process them, people interpret the results, and then words are chosen to describe them. Somewhere along that chain, a careful phrase can become a dramatic one. A block becomes a building, a ridge becomes a road, a mound becomes a pyramid, a pattern becomes a plan. It does not take dishonesty for this to happen. It only takes excitement, uncertainty, and the ordinary human tendency to describe what something resembles. If someone says, "It looks like a pyramid," that can be a fair comparison. But by the time the sentence travels through headlines and retellings, it may become, "A pyramid was found." Those are not the same thing. One is a description of appearance, the other is a claim about origin. The difference may seem small at first, but in archaeology, geology and history, it is large enough to steer the whole ship. That is why the depth matters again. If a pyramid-like feature is found on land, researchers can walk around it. They can measure the angles. They can look for tool marks. They can check whether stones were cut or naturally fractured. They can examine the surrounding area for pottery, charcoal, bones, shells, tools, or other signs of human activity. They can dig small test trenches. They can compare the structure with known sites. They can ask many questions and collect many answers. But when the possible feature is hundreds of meters underwater, even basic questions become expensive. What's it made of? How big is it really? Are the surfaces flat or just appearing flat from one angle? Are the blocks separate or part of bedrock? Is there sediment between them? Are they aligned with faults? Are there artifacts nearby? Is there any evidence of cutting, stacking, paving or construction? Each answer has to be earned. The third difficulty is sea level. This is the part of the story that quietly makes the Lost City idea much harder. There are many real underwater archaeological sites around the world. That is important to say clearly. Ancient people often lived near water. Coasts gave access to food, travel, trade, fresh water sources and fertile environments. During the last ice age, sea levels were lower because large amounts of water were locked in ice sheets. When the ice melted, seas rose and covered landscapes that people may have used. That means drowned human sites are not fantasy. They are part of real archaeology. But the usual sea level change after the last glacial maximum was not enough to cover a city by 600 meters of water. It was around 120 meters, a great change, but not that great. This does not mean nothing human-made can ever be found underwater. It means depth has to be matched with a believable history of how the site got there. A shallow site can be explained by rising seas. A site at several hundred meters needs a much larger explanation. Perhaps tectonic movement, perhaps a landslide, perhaps local subsidence, perhaps something more complex. But each of those explanations brings new questions. Did the land sink? When? How fast? Would a constructed site survive that movement? Would it remain recognizable? Would the geology of the region support such a scenario? Could human beings have built it before the sinking happened? Does that fit the archaeological timeline? It is not enough to say, the sea rose. The sea did rise, but not by that much. This is where a simple mystery begins turning into a difficult scientific problem. For the formations to be an ancient city, they would have to be placed within a chain of events that makes physical sense. They would need a time when the area was dry land, a human culture capable of building on that scale, a geological process capable of moving the site to its current depth, and enough preservation for the shapes to remain visible after thousands or tens of thousands of years under changing conditions. That is a lot to ask of one hypothesis. It does not make it impossible in a purely conversational sense, but it makes it demanding. And demanding claims need strong evidence. Sonar shapes alone are not strong enough. This is probably the least dramatic and most important sentence in the whole story. Sonar shapes alone are not strong enough. That does not mean they are useless. They are often the beginning of discovery. Many shipwrecks, geological formations and archaeological sites are first noticed because something odd appears in remote sensing data. But the data has to be followed. It has to be tested. The Cuban formations have remained famous partly because the follow-up has not been clear enough, public enough or complete enough to settle the question. A mystery can become very loud when evidence is quiet. People begin filling the silence. Some fill it with Atlantis. Some fill it with cover-ups. Some fill it with geology. Some fill it with jokes about ancient urban planners having excellent waterfront property and terrible flood insurance. But the silence itself is not proof of any one answer. It is just silence. There is also a practical side to why deep discoveries often stall. Deep-sea expeditions are expensive, and most research budgets are not built around satisfying internet curiosity. Scientists have to choose between many possible projects. Some have clear environmental importance, some involve climate, fisheries, hazards, ecosystems, or active geological processes. A mysterious formation that might turn out to be natural may struggle to compete for funding unless the evidence is especially strong. That can feel disappointing because from the outside the question seems obvious. Just go look. But just go look in 650 meters of water is not a small request. It is a full operation. The ocean charges a large fee for certainty. Location adds another layer. The formations were reported in Cuban waters, and that means permissions, partnerships, and political realities matter. Marine research is not only science. It is also law, jurisdiction, diplomacy, logistics, and access. A team cannot simply decide to investigate the seafloor of another country, pack a few underwater robots, and appear one morning with cheerful confidence. There are rules, there are authorities, there may be restrictions, there may be sensitive areas, environmental protections, military concerns, or heritage laws. Even when everyone means well, the process can be slow. And when a site is both deep and politically complicated, the path from discovery to certainty becomes even longer. The fourth difficulty is the difference between an anomaly and an artifact. An anomaly is something unusual. It stands out. It does not look like the surrounding area. It asks for attention. An artifact is something made or modified by humans. Those categories can overlap, but they are not the same. The Cuban formations are often treated in popular retellings as if unusual automatically means artificial. It does not. Nature produces anomalies constantly. A cliff face may look like a wall, a field of rocks may look arranged, a circular reef may look like a ring, a volcanic or sedimentary structure may look engineered. Geological processes work through forces that can create order without intention. That is the key word. Intention. Human construction is not only shape, it is shape with purpose. Purpose leaves traces. Repetition alone is not enough. Straight lines are not enough. Right angles are not enough. Large blocks are not enough. A city would need a broader pattern of human use. Streets are not just lines, they connect spaces. Buildings are not just rectangles. They are built with materials handled in particular ways. Settlements usually include debris, tools, food remains, modified surfaces, construction sequences, and context. The deeper the site, the harder those things are to find. But without them, the word city remains more of a nickname than a conclusion. Still, the nickname is powerful. Underwater city beneath Cuba has weight. It sounds like the beginning of a story told by candlelight, or at least by someone with a very serious documentary voice. It carries a promise. It suggests that something huge has been hidden in plain sight, or rather, hidden under plain water. It invites us to imagine towers, roads, plazas, carved stones, and a people whose history vanished beneath the Caribbean. It makes the modern map feel incomplete, and everyone likes the feeling that the map is incomplete, especially just enough to be interesting, and not enough to interfere with tomorrow's errands. The danger is that a strong name can outrun weak evidence. Once a place is called a city, people start asking city questions. Who lived there? What language did they speak? Why did it sink? Were they connected to the Maya? Was this Atlantis? Did they know something we forgot? These are fascinating questions, but they may be questions about a place that does not exist in that form. If the formations are natural, then all those human questions dissolve. The real questions become geological ones. What formed the blocks? What processes created the shapes? Why are they arranged that way? What does this part of the Cuban margin reveal about tectonics, erosion, sedimentation, or ancient seabed change? Those are less sensational questions, but they are still good ones. Rocks have stories too. They just tell them more slowly and with fewer dramatic costumes. The word deep also affects time. A deep site feels old. It may be old, but depth and age are not the same thing. Something can be deep because it formed deep. It does not have to have sunk from the surface. A formation on the seafloor may have developed underwater through geological processes. It may never have been a dry landscape. If that is the case, there is no need to explain how a city sank, because there was no city and no sinking. The site would be deep because it belongs to the deep environment. This is a simple point, but it often gets lost because the mind prefers the more dramatic version. A drowned city feels more exciting than a natural formation that has always been underwater. But the truth does not adjust itself to our entertainment needs, which is frankly inconsiderate. The reported depth also makes comparison to other underwater mysteries tricky. Some people compare the Cuban formations to places like Yonaguni in Japan, where underwater terraces and angular shapes have been debated for years. But Yonaguni is much shallower. Divers can visit it. Photographs and direct observations are easier. Even there, experts disagree about natural versus human modification. If a shallow site can remain debated, imagine how much harder the Cuban case becomes at many times the depth. The more remote the site, the more each interpretation depends on limited evidence. And limited evidence is very good at supporting strong opinions in both directions, which is why the internet enjoys it so much. What would a proper investigation need? It would need high-resolution mapping of the full area, not just selected images. It would need repeat surveys from different angles and with different instruments. It would need detailed bathymetry showing the wider geological setting. It would need video transects with scale references so that apparent blocks and ridges could be measured accurately. It would need samples of the rock, sediment, and any unusual material. It would need analysis by marine geologists, archaeologists, sedimentologists, and perhaps specialists in Caribbean tectonics. It would need the patience to let the evidence decide, even if the answer turns out to be less dramatic than the question. A serious team would likely begin by asking geological questions before archaeological ones. What is the structure of the seabed in this region? Are there faults nearby? Are there known landslide deposits? Is the seafloor made of limestone, volcanic rock, sedimentary layers, or mixed material? Do the forms align with natural fracture patterns? Are the blocks attached to bedrock or separate pieces? Is there evidence of collapse? Are the surfaces weathered in a way that suggests exposure to air, or do they look like underwater rock? These details matter because they can tell us whether the formation belongs naturally where it is. If it does, the city idea becomes weaker. If it does not, the mystery becomes more interesting. Only after that would the human questions gain strength. Are there marks consistent with tools? Are there shaped stones that repeat in size and form in a way natural processes cannot easily explain? Are there artifacts unrelated to local geology? Are there materials transported from elsewhere? Are there patterns that match known construction methods? Are there buried layers that can be dated? Without those pieces, the story remains in the category of possible visual resemblance. And visual resemblance, while exciting, is not enough to rewrite history. History is stubborn. It does not move aside because something looks interesting on a screen. The deep setting also makes preservation uncertain. If there had been a built environment, what would centuries or millennia of deep water conditions do to it? Sediment might cover parts of it. Biological growth might crush surfaces. Currents might expose or bury features. Chemical processes might alter stone. Geological activity might break or shift blocks. A site could be preserved in surprising ways or damaged beyond recognition. Again, this is why direct evidence matters. The ocean does not preserve everything like a museum. Sometimes it protects, sometimes it grinds. Sometimes it hides, sometimes it rearranges the room and refuses to say where it put the chairs. There is a quieter human lesson here too. The Cuban formations remind us how uneven our knowledge of the seafloor still is. We live on a planet mostly covered by ocean, yet the deep ocean remains difficult to map and study in detail. We have better images of some planetary surfaces than of many parts of our own seabed. That fact is often repeated because it is useful, and also because it makes us feel slightly silly. We name streets, argue over property lines, and locate coffee shops within seconds, while vast areas under the sea remain known in broad strokes. The ocean is not empty space between continents, it is terrain. It has mountains, valleys, plains, cliffs, channels, vents, scars, and records of Earth's past. A strange formation at depth may not be a lost city, but it is still part of that hidden terrain. So perhaps the best way to hold this discovery is not as a solved claim, but as a difficult invitation. It invites us to think about how evidence works when the place being studied is hard to reach. It invites us to separate wonder from certainty. It invites us to notice how quickly language can turn resemblance into declaration. It invites us to respect the ocean as an environment that does not give up answers easily. And it invites us to admit that sometimes the most honest sentence is not, "we know," but "we do not know yet." That sentence can feel unsatisfying. It leaves the mind wanting more, but it is also where real discovery often begins. The Cuban formations sit beneath too much water for easy answers, and that may be why they have remained so persistent in public imagination. They are deep enough to resist quick confirmation, strange enough to resist quick dismissal, famous enough to attract speculation, unstudied enough to keep the speculation alive. They are not only a possible site, they are a lesson in how the unknown survives, and now, with the depth in mind, the sonar images become even more important. Because for a long time, the shapes on those screens were the main bridge between the world above and the formations below. Sound became sight, echoes became outlines, shadows became evidence, or at least the beginning of evidence. To understand why people saw streets, blocks, and stone-like patterns, we have to spend a little time with the strange art of looking at the seafloor through sound. To understand why the Cuban underwater formations became so interesting, we have to spend a little time with the strange way humans look at places we cannot actually see. The deep ocean does not offer itself to us in a simple way. It does not lift the curtain, turn on the lights and say, "Here you are, have a careful look." At hundreds of meters below the surface, the water is dark, the pressure is high, and even a very determined person with a strong flashlight and a packed lunch is not going to be much use. So we use machines, we send down sound, we listen for echoes, then we turn those echoes into images and ask our eyes to make sense of them. That is already a curious thing when you stop and think about it. The first public excitement around the formations near Cuba did not come from someone standing in front of a wall, or touching a carved stone, or brushing sand away from the corner of a doorway. It came from sound. A pulse moved through seawater, hit the seabed, bounced back, and became data. The data became a picture. The picture became a question. And that question, once it reached the human mind, began growing all sorts of possibilities around itself. Sonar can feel almost magical from a distance, but its basic idea is practical. A device sends sound into the water. Sound travels very well underwater, much better than light in many deep or murky settings. When that sound reaches something, part of it reflects back. The system measures how long the return takes and how strong it is. From that, researchers can estimate distance, shape, hardness, height, slope, and texture. With enough passes over an area, a map begins to form. Not a normal photograph, but a kind of sound-built picture of the seafloor. This is where the story becomes both useful and tricky. A sonar image is not the same as a photograph taken in clear daylight. It is more like a translation, and, like all translations, something depends on the method, the angle, the resolution, and the person reading it. A hard object can return a strong signal. A soft area, such as mud or loose sediment, may return a weaker one. A raised object can create a shadow behind it, not a shadow made by light, but an acoustic shadow, a place where the sound could not reach clearly because something stood in the way. Those shadows can be extremely helpful. They can reveal height and shape. They can also make things look more dramatic than they really are, which is very considerate if you are writing a mystery story, and less convenient if you're trying to classify a rock. Imagine placing a small block on a table and shining a lamp across it from the side. The block itself is clear enough, but the shadow stretches behind it, making the object look larger and more important. Now imagine doing something similar underwater, except the lamp is sound, the table is the seabed, the object may be a rock, and the viewer is a computer screen far above. A long shadow might mean a tall feature, or it might mean the angle of the sonar made a modest feature look more pronounced. A dark return might mean a hard surface. Or it might mean a surface facing the sonar in just the right way. A pale area might be soft sediment, or it might be a shadow. Interpretation is not guesswork, but it is not automatic either. That is why the Cuban case is so delicate. The reported shapes were seen first as sonar patterns. They appeared, according to early descriptions, as large geometric forms on the seabed. There were references to block-like structures, pyramid-like forms, and patterns that seemed arranged. It is easy to understand why that caused excitement. A sonar image of ordinary seafloor may show ripples, slopes, scattered rocks, channels, or rough terrain. But when a field of shapes appears to include straight edges, repeated forms, and large features that seem to sit in relation to one another, the mind begins to ask whether those shapes are just geology, or whether something else might be going on. The phrase, stone-like patterns, is useful because it does not force an answer too early. Stone-like does not mean built. Pattern does not mean plan. But a pattern still matters. It means something about the seabed caught attention. Something in the returns seemed different enough to be noticed. The challenge is that natural seafloors can be surprisingly patterned. Sediment can form waves, ridges, and repeating lines. Rock layers can fracture into rectangular slabs. Faults can cut long, straight features across terrain. Blocks can break from a slope and settle in clusters. Limestone can dissolve and erode in ways that create ledges, steps, and pits. Volcanic rock can form columns or angular masses. A seabed shaped by geology can look, from the right angle and at the right resolution, a little like someone had been organising it. There is a quiet lesson there. Human beings often treat straight lines as suspicious. We see a straight edge and think, someone made that. In daily life, that is usually a fair instinct. Houses have straight walls, roads have straight edges. Tables, books, windows, tiles, doors, screens, shelves, and cereal boxes are all full of geometry. Our built world trains us to associate straightness with intention. But Earth has its own geometry. Crystals grow in ordered forms, mud cracks in polygons, rocks split along weaknesses, basalt can cool into columns, layers can break into slabs, ice can fracture into angles, salt can form repeating patterns. Nature is not a person with a measuring tape, but it still follows physical rules, and rules often produce order. The deep ocean adds another layer of confusion because scale can be hard to judge. A feature that appears small on a screen might be enormous. A feature that appears sharply defined might be softened by sediment. A surface that appears flat might be angled toward the sonar. Without clear scale markers, direct samples, and repeated observations, the brain tries to fill in the missing information. It asks, how tall is that? How sharp is that corner? Is that a separate block or part of a larger outcrop? Is that line a road, a crack, a ridge, or a shadow? The screen can suggest. It cannot always confirm. This is why researchers often combine different tools. Side-scan sonar is excellent for producing image-like views of the seabed surface. Multi-beam sonar can create detailed maps of depth and shape. Sub-bottom profilers can look into layers beneath the seafloor. Cameras and remotely operated vehicles can provide visual confirmation. Samples can reveal what the material actually is. Each tool answers a different part of the question. One says, here is a shape. Another says, here is its height. Another says, here is what lies beneath. Another says, here is what it looks like up close. A sample says, here is what it is made of. A serious investigation needs several of these voices speaking together. In the Cuban story, the sonar images were the loudest voice at the beginning. They were interesting enough to inspire claims, but not enough by themselves to settle the matter. That is a difficult place for a mystery to live. The images are not meaningless. They are the reason the story exists. But they are not proof of a city. They are an invitation to investigate further. A map made by sound can point to a place where better evidence might be found. It cannot all alone provide streets, buildings, builders, dates, and culture. There is also the matter of resolution. A low-resolution image can make features look smoother or more regular than they really are. It can blend small details into larger shapes. A rough pile of rocks might become a single blocky mass. A jagged ridge might look like a wall. A cluster of natural forms might seem aligned. A higher resolution survey might clarify the scene, or it might complicate it. Sometimes better data makes a mystery more exciting. Other times, better data quietly removes the drama, like turning on the bedroom light and discovering the monster in the corner was a coat over a chair. A disappointing result for the monster, perhaps, but useful for sleeping. Processing matters too. Sonar data does not leap from the ocean into a perfect image. It may be cleaned, corrected, stitched, shaded, filtered, and displayed in ways that affect how features appear. Different colour scales, contrast settings, viewing angles, and shading can make the same terrain look more or less artificial. This does not mean people are being deceptive. It means data visualization is a craft. A map is not only a recording, it is also a presentation. And presentation influences perception. Anyone who has ever taken a photo of a meal and made it look either delicious or deeply unfortunate understands this principle on a smaller and more edible scale. When people first saw the Cuban sonar patterns, it seems that repetition played a major role in the excitement. One odd shape can be dismissed more easily. A field of odd shapes is harder to ignore. If there are many block-like forms, many straight lines, many apparent alignments, then the mind begins asking whether random geology is enough. That is a fair question. Repetition is one of the things archaeologists do look for. Human construction often produces repeated units, repeated orientations, repeated sizes, repeated relationships between spaces. But geology can repeat too. The key is whether the repetition fits natural processes or goes beyond them. For example, a natural rock layer may fracture into blocks of similar size because stress moves through the material in a consistent way. A seabed slope may produce terraces because layers of different hardness erode at different rates. Currents may shape sediment into waves that repeat across a field. Faults may create parallel lines. A landslide may scatter blocks downslope, where they come to rest in patterns controlled by gravity, slope angle, and seafloor shape. None of that requires builders, it requires conditions. This is one reason a marine geologist may look at a supposedly artificial pattern and see a natural process immediately, while a non-specialist sees a plaza, a wall, or a street. The reverse can happen too. Sometimes specialists become so used to natural explanations that they can overlook human traces if those traces are subtle or unexpected. That is why good investigation works best when different experts are involved. An archaeologist may notice cultural patterns. A geologist may notice rock structure. A sonar specialist may notice imaging artifacts. A sedimentologist may notice burial processes. An engineer may notice whether blocks could have fallen naturally. Each person brings a different kind of caution. Together they reduce the chance that one exciting idea runs off with the whole story, while everyone else is still putting on their shoes. There are famous examples around the world of underwater places that sparked debate because of their shapes. Some are accepted archaeological sites, others are natural formations with dramatic geometry, others remain argued over. The reason these debates continue is that underwater evidence is often partial. The sea changes surfaces, hides context, moves sediment, and makes excavation difficult. A shape that would be easy to judge on land becomes harder underwater. A line in a field can be walked. A line in deep water has to be mapped. A stone on land can be turned over. A stone at 650 meters needs a machine with a mechanical arm, a ship above it, and someone who knows which button not to press at the wrong time. This is also why the Cuban formations have an unusual kind of public life. Many people know the headline version. Far fewer have seen enough data to judge the case. The story is carried by descriptions: geometric, symmetrical, block-like, pyramid-like, city-like. These words are vivid. They are also slippery. Like is doing a lot of work. A thing can be pyramid-like because it has sloping sides, not because anyone built it for ritual, burial, astronomy, or anything else. A thing can be city-like because it has repeated shapes, not because people lived there. The word like can be a helpful comparison, but it can also quietly smuggle in a conclusion. It opens the door, then pretends it was only checking the handle. A careful script has to leave that door open without pushing the audience through it. So let us imagine the sonar display as honestly as possible. Not as a clear photograph of roads and temples, not as a random blank seafloor either. Imagine a spread of unusual returns in deep water. Large forms, some angular, some arranged in ways that look regular. Bright and dark areas showing hard surfaces, slopes and shadows, lines that might be edges, blocks that might be outcrops, gaps that might be channels, a pattern that makes the viewer pause. That pause is real. The conclusion is not. The shadows are especially important. Acoustic shadows can give a sonar image its sense of drama. They help reveal height by showing where sound was blocked. But they can also exaggerate the impression of steep walls or upright forms. A low ridge may cast a long shadow depending on the angle. A rough surface may create patches of dark and light that look like separate objects. A field of boulders can look like an arranged scatter of blocks. In a deep-sea setting, where no diver can easily check the view, the shadow becomes both evidence and trickster. It says something is raised here. It does not always say exactly what. Stone-like patterns can also result from bedding. Sedimentary rocks form in layers. If those layers are cut, tilted, broken or exposed, they may appear as flat slabs. Underwater erosion can remove softer material and leave harder layers standing. The result may resemble steps, platforms or walls. In limestone areas, dissolution can create sharp cavities and blocky surfaces. In tectonically active regions, fractures can divide rock into rectangular sections. The Caribbean region has a complex geological history, with plates, faults, basins, uplift, and subsidence shaping the seafloor over long periods. A strange-looking seabed near Cuba does not have to be human-made to be geologically interesting. It may be telling a story about Earth movements rather than ancient streets. Still, there is a reason the city idea has such staying power. Sonar images can feel like secrets. They look technical, almost official, as if the machine has removed human bias and revealed pure fact. But machines do not remove interpretation, they move it to another stage. These sonar records physical responses. Humans choose how to process them, view them, label them, and explain them. This is not a weakness of sonar, it is simply how measurement works. Even in ordinary life, a thermometer gives a number, but you still decide whether the room feels comfortable. A clock gives the time, but you still decide whether it is too early to get up. The machine informs us. It does not do all our thinking for us, which is probably for the best, though some mornings one might welcome the assistance. The Cuban formations also remind us that mystery often begins at the edge of visibility. If a camera had shown clear tool marks, carved stones, pottery or walls with construction joints, the story would be very different. If a later survey had shown nothing but ordinary ridges, the story would also be different. But sonar shadows and stone-like patterns sit between those extremes. They are visible enough to invite interpretation and unclear enough to resist it. That makes them perfect fuel for speculation. The mind keeps returning to them because they do not close the case. A responsible investigation would want to know whether the apparent patterns continue beyond the famous area. If they do, that might suggest a broader geological formation. If they stop abruptly, that might be interesting. Researchers would want to know the orientation of the lines. Do they align with known faults or bedding planes? Do they follow the slope of the seabed? Are they distributed in a way expected from landslide debris? Do they show regular dimensions beyond what natural fracturing would create? Are there repeated right angles that remain clear from multiple survey directions? These questions are not glamorous, but they are how mystery becomes knowledge. They are the slow work behind any honest answer. The sonar would also need to be compared with visual inspection. A remotely operated vehicle could move close to the features, shine lights across surfaces and film them with scale markers. Even then, the team would need to be careful. Deep-sea lighting creates its own shadows. Cameras distort distance. Sediment can cover important details. A rock face seen in one pass may look artificial, then natural when viewed from the side. The best evidence comes from patient mapping, not one dramatic clip. One image can start a conversation. Many measurements can finish one. And if samples were taken, they would be crucial. A rock sample could reveal whether the material is local bedrock, transported stone, coral limestone, volcanic rock, or something else. Microscopic analysis could show weathering history. Chemical tests could compare the sample with nearby formations. If a supposed block is simply part of a natural outcrop, the sample may show continuity. If it is a separate stone from somewhere else, that could raise new questions. If there are signs of cutting, shaping, or working, those would matter greatly. But until such evidence is available and independently examined, the sonar patterns remain suggestive rather than decisive. That may sound like a very careful way to talk about a mystery, and it is, but careful does not mean cold. There is still something deeply compelling about those first sonar impressions. Picture the research vessel moving over dark water, the surface perhaps calm, perhaps not, while beneath it the sound pulses travel downward and return with news from a place no one on board can see. On the screen, the seafloor begins to organise itself into forms, lines, blocks, shadows, a texture that seems different from the surrounding bottom. The people watching lean in. Someone checks the readings. Someone asks for another pass. The ordinary work of mapping becomes, for a moment, a small encounter with the unknown. That small encounter is where many discoveries begin. Not with certainty, but with a shape that does not fit expectations. A fossil in the wrong layer, a signal from the wrong part of the sky, a stone tool where no one expected people to have lived, a sonar return that looks too regular to ignore. Sometimes the follow-up reveals something extraordinary. Sometimes it reveals a natural process that is extraordinary in a different way. Sometimes it reveals that the first impression was mostly an illusion. All three outcomes are part of science. The trick is to let the evidence decide which one we have. With the Cuban formations, the evidence available to the public has never fully caught up with the story. That is why the sonar shadows still matter so much. They are not just details. They are the foundation on which the popular mystery was built. If the original interpretation was too enthusiastic, the city may vanish into geology. If the patterns are more regular than skeptics assume, the site deserves renewed attention. Either way, the next step is not louder claims, it is better data. For now, the formations remain a lesson in how strange the seafloor can look when seen through sound. Sonar gives us a way to enter the dark without entering it ourselves. It lets us trace hidden terrain, find wrecks, map ridges, study habitats, and notice things that would otherwise remain unknown. But it also asks for humility. A shadow can guide us, but it can also mislead. A straight line can point toward human work, or toward a fracture in stone. A pattern can be a plan, or it can be physics wearing a convincing disguise. So the question becomes less simple and more interesting. Not just, did someone build this, but what kinds of natural forces can build shapes that look almost built? Because nature, given enough time, pressure, movement and material, can create forms that test our instincts. It can arrange stone without intention. It can make steps without stairs, walls without rooms, and blocks without builders. And that is where the next part of the story begins, with the possibility that the most city-like thing beneath Cuba may not be a city at all, but a reminder that Earth has its own slow talent for architecture. Nature does not build cities in the human sense. It does not plan neighbourhoods, mark out streets, raise walls, or decide that one block should be residential and another should be for shops, workshops, temples, storage rooms, or that one oddly placed public square where pigeons seem to run the local government. Nature has no council meetings. It does not argue over permits. It does not forget where it put the measuring tools. And yet, when given enough time, enough pressure, enough water, enough heat, and enough rock, nature can produce shapes that look uncomfortably close to human design. That is the uncomfortable little problem sitting at the centre of the Cuban underwater formations. These sonar patterns appeared strange because they seemed geometric. They seemed structured. They seemed to show blocks, lines, and forms that some people thought looked arranged. And to the human eye, arrangement feels meaningful. A field of scattered stones is one thing. A field of stones that seems to have straight edges, repeated spacing, and broad shapes that could be read as streets or platforms is another. But geology is full of forms that make the eye pause. The earth has been cracking, folding, dissolving, cooling, lifting, dropping and breaking stone for far longer than humans have been stacking it. So the question is not simply whether nature can build a city. The more useful question is whether nature can build something that, from sonar data and deep water video, might look enough like a city to start a story. And the answer to that is yes. Nature can do that rather well. Sometimes a little too well, as if it knows we're watching and enjoys making us uncomfortable. Start with cracks. That sounds modest, but cracks are one of geology's great designers. Rock is not always a solid, featureless mass. It has weaknesses. It has layers. It has stress. It expands, contracts, bends, cools, dries, shifts, and responds to forces around it. When stress builds, rock can fracture along joints. These joints can run in sets, sometimes crossing each other at angles that create blocks. In some places, joint systems produce rectangular, square, or ladder-like patterns. If you saw them from above, especially with sand or sediment filling the gaps, you might think of paving stones, foundations, or the outlines of a ruined settlement. But no person has to cut them. The rock breaks that way because the forces acting on it are organised. Limestone is especially good at creating misleading surfaces. Much of the Caribbean region includes carbonate rocks in one form or another, and limestone has a habit of dissolving when water works its way through joints, cracks, and bedding plains. Over long periods, slightly acidic water widens those cracks. On land, this can create karst landscapes with caves, sinkholes, channels, and exposed limestone pavements. A limestone pavement may look like a flat stone floor divided into blocks, with deep grooves between them. The blocks are called clints, and the grooves are called grikes. That sounds like the name of a pair of sleepy village cats, but it is real geology. USGS cast terminology describes limestone pavement as a surface divided into blocks by solution-widened joints, which is exactly the sort of natural process that can make stone look organised without any builders involved. Now picture something like that underwater, partly buried, viewed not from a standing human body on a hillside, but through sonar from hundreds of meters away. Flat surfaces could look like platforms, widened cracks could look like roads, blocks could look like masonry. If some parts were covered by sediment and other parts were exposed, the visible pattern might seem even more selective, almost designed. The brain would naturally begin connecting the open lines into a plan. It might say, there is a road here. But the rock might only be saying, in its very slow rock way, water got into my joints for a long time. This is not only a limestone issue. Volcanic rock can also produce highly regular forms. When thick basalt lava cools, it contracts. That contraction can create columnar joints, often with hexagonal patterns. Famous places such as Giant's Causeway in Northern Ireland and Devil's Postpile in California are known for this kind of natural geometry. The US Geological Survey describes these hexagonal cracks as a common result of thick basalt lava flows cooling. The National Park Service also explains that columnar jointing consists of regularly spaced fractures that form prismatic columns, usually hexagonal, though not always. If a person who had never seen columnar basalt before came across it at night with a weak flashlight, they might be forgiven for thinking someone had built it. The columns can look like pillars. The broken tops can look like paving. The regular spacing can look engineered. Nature does not need a chisel. Cooling and contraction are enough. This does not mean the Cuban formations are columnar basalt. The point is simpler. Geology can produce straightness, repetition, and pattern. Those qualities do not automatically belong to human construction. Then there are bedding planes. Sedimentary rocks are often laid down in layers. Those layers can be flat or tilted, thick or thin, hard or soft. If erosion removes the softer parts and leaves the harder layers standing, the landscape may develop steps and ledges. From a distance, these can look like terraces. Underwater, they can look like walls or platforms. If the layers break across joints, the result can be a set of blocky shapes with straight edges. Add shadows from sonar and the impression becomes stronger. A ledge becomes a wall. A gap becomes a street. A fallen slab becomes a roof. A natural terrace becomes a plaza. The mind keeps building. Landslides can add to the confusion. Underwater slopes fail just as slopes on land do. Sediment and rock can collapse, slide, tumble, and settle in new positions. Large blocks may break off and come to rest downslope. Depending on the shape of the slope and the original rock layers, the blocks may appear clustered or aligned. They may look stacked. They may be partly buried in sediment, making them seem as if they sit on a surface rather than having fallen into one. A field of landslide blocks can have an almost architectural look, especially if the blocks are large and angular. It may resemble ruins, but the builder was gravity, which has a very long career and no known retirement plan. Faulting can create another kind of order. A fault is a break in the Earth's crust where rocks have moved relative to each other. Faults can produce long linear features, sharp scarps, offset layers, and repeated fractures. On sonar, a faulted seabed might show lines that look like roads or walls. If several fault sets intersect, the pattern may become grid-like. Humans love grids. Cities often have grids, but rock can fracture in grids too. The difference lies in context, detail, and evidence. A city grid is designed around movement and use. A fracture grid is controlled by stress. From far above or through remote sensing, the two can be easier to confuse than we would like. The seafloor itself is not still. Currents can shape sediment into waves, ripples, ridges, and channels. These can repeat across wide areas. Sediment can collect against hard objects. burying parts of them and exposing others. Currents can scour around blocks, making them appear isolated and more prominent. Over time, the seabed may become a patchwork of hard rock, soft sediment, exposed ridges, and filled grooves. Sonar sees these differences as stronger and weaker returns. A explains that side-scan sonar images are formed from dark and light areas based on how strongly sound reflects from the seafloor, with hard raised objects and shadows affecting the image. That matters because a sonar pattern is not just a map of shapes, it is also a map of sound behaviour. A hard surface facing the sonar may return a strong signal. A shadow behind a raised feature may look like a gap. A soft sediment pocket may look like an empty space. When these effects combine, they can make a natural landscape look more structured than it would under direct inspection. It is a little like seeing furniture in a dark room by the shape of its shadows. You can learn a lot, but you may also mistake the laundry basket for a crouching intruder, which is one of the less dignified ways to start the evening. This is why the Cuban formations are so difficult to judge from the outside. A person reading about them sees the words geometric, symmetrical, blocks, pyramids, and city. Those words immediately create a mental image, but the actual evidence began as remote sensing in deep water. To decide whether nature built the shapes, researchers would need to know the local geology in detail. What kind of rock is there? Are the formations attached to bedrock? Are they broken layers? Are they part of a slope failure? Do they follow natural fracture directions? Are the blocks of local material? Are there tool marks? Are there artifacts? Are there sediments between the stones that can be dated? Are there signs the surfaces were ever exposed to air? That last question is very important. If the formations were once a human-built place, they would need to have been on dry land, or at least shallow enough for people to build there. But the reported depth, around 600 to 750 metres, is far below the amount of global sea level rise since the last glacial maximum. USGS states that sea level during that time was more than 400 feet lower than today. 400 feet is a lot, roughly 120 metres, and enough to drown many ancient coastal landscapes. It is not enough to explain a supposed city resting hundreds of metres below the surface near Cuba. This does not automatically prove the formations are natural, but it does mean the human-made explanation needs a second large event. The site would not only need to have been built, it would also need to have sunk dramatically, or been carried downward by some geological process, or formed in a way that changes the usual sea level argument. That is a heavy burden. Geology can move land, yes. Coastlines can rise and fall, faults can shift, margins can subside. But moving a whole built environment to that depth while preserving recognisable forms would require a very specific and well-supported story. Without that story, nature becomes the simpler explanation. And in science, simpler does not mean lazy. It means fewer unsupported assumptions. A natural formation requires rock, stress, erosion, sediment, movement, and time. Those are all available. A lost city at that depth requires all of those things, plus an unknown building culture, a dramatic submergence history, preserved architecture, and evidence that has not yet been clearly shown. That does not make it impossible in the way turning a teacup into a live pigeon is impossible, at least outside certain parties. It makes it unlikely unless stronger evidence appears. There is another useful distinction here. Nature can build city-like shapes, but it does not build city-like function. This is where archaeologists become very careful. A true city is not only a pattern of stone, it has use, it has organisation, it has repeated human behaviour preserved in material form. There may be roads because people moved between places. There may be foundations because buildings stood there. There may be drains, hearths, pottery fragments, worked stone, burials, tools, refuse areas, food remains, or changes in soil chemistry. On land, these traces can be subtle but detectable. Under deep water, they are harder to find, but they are still the kind of evidence that would change the conversation. A natural formation may mimic the appearance of walls, but it will not contain door thresholds worn by feet. It may produce flat blocks, but not the same construction sequence repeated in building after building. It may create lines, but not road surfaces with associated artifacts. It may create a terrace, but not a settlement layer with domestic debris. Shape is the first clue. Context is the test. Without context, the city remains an interpretation placed on top of the shapes. This is also why people sometimes disagree so strongly about sites like these. A geologist may look at a blocky pattern and think of jointing, bedding, collapse, or cast. An archaeologist may look for cultural signatures and find none. A sonar specialist may notice that the image angle makes the forms look sharper than they are. A curious viewer at home may see the same image and feel certain that it is a plaza. Each person is not only seeing the image, they are seeing it through training, expectation, and desire. That does not make all interpretations equal, but it does explain why the debate can become so lively. It is tempting, very tempting, to think that nature would be messier than this. We imagine natural things as irregular and human things as ordered, but that is only partly true. A forest is messy up close, but the branching of trees follows rules. A river meanders, but its bends obey physics. A shell spirals. A snowflake grows with symmetry. A beehive forms hexagons. Though bees are animals, not geology, and they are also far better at teamwork than most office departments. A crystal grows with regular faces. A coastline repeats curves at different scales. A drying lake bed cracks into polygons. A lava flow cools into columns. The natural world is full of order because order can emerge from simple repeated forces. The word emerge might sound a little grand, but the idea is practical. If the same process acts on the same material under similar conditions, similar shapes can appear again and again. Lava cooling evenly creates regular fractures. Limestone dissolving along joints creates repeated blocks and grooves. Sediment moved by currents creates ripples. Stress in rock creates fracture sets. None of these processes has a plan, but they have consistency. The result can look planned because physical rules do not behave randomly. They behave like physical rules. That may be the most useful way to think about nature as an architect. It does not design, it repeats. It does not imagine, it responds. It does not build for meaning, it forms through process. And sometimes process creates forms that resemble meaning so strongly that we have to stop and check ourselves. The Cuban formations may be one of those cases. The reported shapes could be a natural rock field shaped by jointing, erosion, collapse, or tectonic movement. They could be a hard seafloor pattern made more dramatic by sonar shadows. They could be blocks created by fracture and later partly buried. They could be a combination of several processes. They might still deserve further study, because natural does not mean uninteresting. A deep-sea formation that resembles ruins could reveal something important about the geology of the Cuban margin. It could show ancient slope failures, unusual rock exposure, fault patterns, or carbonate processes. A geological answer would not make the story worthless. It would simply change what kind of story it is. That is something worth remembering. People often treat the natural explanation as the boring one, as if the only exciting answer is a forgotten civilization. But a natural formation at hundreds of meters depth, shaped into blocks and patterns by Earth processes, is not boring. It is the planet showing its workmanship. It is a reminder that the seabed is not a flat, empty floor, but a complex landscape with its own history. The rocks beneath Cuba may not hold streets, but they may hold records of uplift, collapse, erosion, and old environments. They may not tell us about lost citizens, but they may tell us about a moving Earth. Still, the pull of the city idea remains. It remains because human beings connect stone with story. We walk through ruins and feel time immediately. A wall without a roof still feels like a room. A road with no travellers still feels like movement. A step worn smooth still feels like feet. So when we hear about stone blocks beneath the sea, The imagination supplies the missing people. It places lamps in windows that may never have existed. It adds footsteps to surfaces that may only be fractures. It hears voices in a place that may never have known a human voice. This is not foolish. It is human. But it has to be separated from evidence gently, like taking a very interesting object away from a child who has decided it is definitely a moon rock. There is one more reason the natural explanation deserves respect. If the formations are natural, they may help explain why other underwater cities appear in stories around the world. Many coastal and underwater anomalies begin the same way. Someone sees straight lines, blocks, terraces, or circles. The shapes are real. The interpretation may be wrong. Over time, the site becomes famous not because it is proven, but because it is suggestive. People keep returning to it, hoping the next image will settle the matter. Sometimes it does, sometimes it does not. In the meantime, the formations live in the gap between geology and archaeology. That gap is not a bad place to visit. It teaches us how to look carefully. It teaches us that wonder should not be rushed into belief. It teaches us that skepticism should not be used like a broom to sweep away every strange thing before it's examined. The best position is patient curiosity. Yes, nature can make stone patterns that look built. Yes, the Cuban formations are too deep for an easy drowned city explanation. Yes, stronger evidence would be needed before calling them artificial. And yes, the site remains interesting because those facts do not erase the original strangeness. If a future expedition mapped the area in high resolution, took samples, and showed that the formations were natural fractured limestone or another geological structure, that would be a satisfying answer. Not the answer everyone wants, perhaps, but a real one. If the expedition found tool marks, transported materials, artifacts, or construction details that could not be explained naturally, that would be extraordinary. But extraordinary evidence has not yet appeared in a form strong enough to change the accepted picture. Until then, nature remains the leading builder in this story. Not a builder with hands, not a builder with plans. A builder through pressure, water, fracture, and time. A builder that can make a floor without a house, a wall without a room, a step without a staircase, and a city-like pattern without a city. That may be less dramatic than a lost civilization beneath Cuba, but it is still strange enough to keep us awake for a little while, which is slightly inconvenient for a sleep video, but we will forgive it. And yet, even after all that careful geology, even after the sensible explanations and the stubborn problem of depth, one word keeps swimming back into the conversation. It is a word that appears whenever stone meets ocean, whenever mystery meets old maps, whenever people imagine a place swallowed by the sea. The word is Atlantis, and once it arrives, it tends to make itself comfortable, and that is where Atlantis quietly enters the room. It does not knock. It rarely does. Whenever people hear about strange stone shapes beneath the sea, especially shapes described as geometric, arranged, or city-like, Atlantis tends to appear almost automatically. It brings with it old maps, dramatic music, glowing temples, lost wisdom, vanished kings, and usually at least one person saying, with great confidence, that mainstream history is afraid of the truth. Atlantis is not just a story anymore, it has become a reflex. Mention underwater stones, and someone somewhere will lean forward and whisper the word as if they have just solved a puzzle that has been waiting for them personally since childhood. The Cuban underwater formations were almost designed by circumstance to attract that kind of comparison. They were reported in deep water. They were said to show large blocks and geometric patterns. They were found in the Caribbean, a region already full of old sea routes, shipwrecks, colonial history, indigenous history, hurricanes, reefs, and blue water that seems to invite mystery. The first descriptions were dramatic enough to travel well. A possible city beneath Cuba, stone structures under the waves, pyramids on the seabed. A lost world hidden where sunlight cannot reach. It is not difficult to see why people began reaching for Atlantis. The story practically placed the word on the table and waited. but Atlantis is a complicated guest. The original account does not come from a modern expedition, a carved tablet, a recovered archive, or a set of ruins found under the sea. It comes from Plato, the Greek philosopher, writing more than 2,000 years ago. In his dialogues, Atlantis is described as a powerful island civilization located beyond the Pillars of Hercules, usually understood as the area around the Strait of Gibraltar. In the story, Atlantis becomes wealthy, ambitious, and aggressive. It wages war. It declines morally. Then, in a sudden disaster involving earthquakes and flooding, it disappears beneath the sea. That is the basic source. Not a Caribbean map, not a Cuban legend, not a sonar report, a philosophical story from ancient Greece. That does not make it unimportant. Plato's account is one of the most influential lost world stories ever written. It has shaped literature, speculation, archaeology, pseudoscience, fantasy, film, and late-night conversations that begin sensibly and end with someone drawing triangles on a napkin. But the fact that the Atlantis story is old does not mean every underwater mystery belongs to it. A story can be powerful without being a location key. It can inspire curiosity without providing coordinates. Atlantis is often treated like a missing object that must be somewhere, as if Plato misplaced an island and we only need to check enough oceans, but it may not work that way. Many scholars have read Atlantis as a moral and political tale. Plato often used stories to explore ideas about society, virtue, power, order, and decline. Atlantis can be understood as a warning about arrogance and corruption, a contrast with an idealized Athens, and a way to discuss how societies lose balance when wealth and ambition outrun wisdom. That does not sound as exciting as ancient super city found near Cuba, but it's probably closer to the world Plato was writing in. Philosophers are not always trying to give treasure hunters helpful directions. Sometimes they are making a point. This is disappointing if you have already bought a diving helmet, but it matters. Still, the Atlantis temptation is understandable. There is something deeply satisfying about the idea of a lost civilization under the sea. It gives the ocean a memory. It suggests that the world we know is only the latest version, with earlier chapters hidden below the surface. And, in a limited sense, that is true. Not necessarily with Atlantis, but with submerged landscapes. Real places once lived on by humans are now underwater. Coastlines shifted after the last ice age. Land bridges vanished. River valleys flooded. Ancient camps, forests, and settlements have been found beneath shallow seas in different parts of the world. The sea has swallowed human places before. That part is not fantasy. The trouble is that real submerged archaeology usually follows the numbers. If sea level rose by around 120 meters after the last glacial maximum, then many ancient coastal areas now lie underwater at depths that fit that change. A site 10 meters down can be very plausible. A site 30 meters down can be plausible. A site 80 meters down can still fit into the broad story of rising seas, depending on the local setting. But a site reported around 600 to 750 meters deep does not fit so easily. That is not a small difference. That is not a tiny rounding error. That is not the sea accidentally adding an extra zero because it had a long day. It is a major obstacle. This is where the Atlantis comparison begins to stretch. To connect the Cuban formations to a lost human city, one has to explain not only the shapes, but the depth. A city cannot simply be placed hundreds of meters underwater by ordinary post-ice age sea level rise. Something else would have to happen. A huge geological movement, a dramatic sinking, a landslide, some local tectonic process, and then the site would also need to remain recognizable. Those are very large requirements. Each one needs evidence. Without that evidence, the Atlantis idea becomes less an explanation and more a costume placed over an unknown formation. There is also the matter of geography. Plato's Atlantis was placed beyond the Pillars of Hercules, tied to the world known to the ancient Mediterranean. Many people have proposed different locations over the centuries, from the Atlantic to the Mediterranean, from islands to coastlines, from real places to completely imagined ones. Some theories are serious attempts to connect Plato's story with known disasters, such as the eruption of Thera and the disruption of Minoan civilization. Others are less careful and more energetic, which is a polite way of saying they gallop straight past the evidence while waving a flag. Cuba is far from Plato's described setting. To place Atlantis there, one has to reinterpret the original story very freely. Of course, people do reinterpret it. They always have. Atlantis has been moved around the globe so many times that if it were a real city, it would probably be exhausted by now. It has been placed near Spain, in the Azores, in the Sahara, in Antarctica, near the Bahamas, in the Mediterranean, in South America, and in many other locations. The reason this happens is partly because Plato's description contains enough detail to feel specific, but enough ambiguity to invite argument. It is like a recipe with exact measurements for ingredients no one can identify. Everyone believes they can reconstruct the dish, and somehow it always ends up tasting like their favourite theory. The Cuban formations joined that long list because they had the right ingredients for public imagination. Underwater, large, geometric, mysterious, poorly resolved, difficult to reach, near a region associated in popular culture with lost worlds and ancient mysteries. And because the evidence was not complete, the empty spaces were easy to fill. Atlantis thrives in empty spaces. It grows where data is thin, where photographs are unclear, where official reports are limited, where the ocean is deep, and where people feel that something important is being overlooked. It does not need proof to survive. It needs possibility. That does not mean every person interested in Atlantis is foolish. Many are simply curious. They love old stories. They love the idea that history might be bigger than the version they learned in school. They enjoy mysteries because mysteries make the world feel less finished. There is nothing wrong with that. Curiosity is a good thing. Wonder is a good thing. The problem begins when the desire for wonder becomes stronger than the evidence. Then every straight line becomes a wall, every block becomes a temple, every unknown becomes a cover-up, and at that point the mystery stops being investigated and starts being protected from investigation, which is a strange fate for something that supposedly wants to be discovered. The better approach is to let Atlantis be what it is, a powerful comparison, not a conclusion. It can help us understand why the Cuban formations captured attention. It can show us how deeply the image of a drowned civilization lives in the human mind. It can explain why a sonar pattern became a global story, rather than a quiet geological note. But it cannot by itself identify the formations. Saying this reminds people of Atlantis is reasonable. Saying therefore this is Atlantis is not. It is also worth noticing how the Atlantis idea changes the way people look at evidence. If you begin with the thought that you may be looking at a lost civilization, the evidence seems to arrange itself around that thought. A line becomes a street because a city needs streets. A block becomes a building because a city needs buildings. A mound becomes a pyramid because ancient mysteries seem to require pyramids, even when they have not been formally invited. The interpretation begins to select details that support it and ignore details that do not. This happens to everyone in some form. It is called confirmation bias, though it sounds more like a minor office problem than one of the great engines of human misunderstanding. A skeptical person can have a bias too. They may look at the same shapes and dismiss them too quickly because many Atlantis claims have been weak in the past. That is also not ideal. The goal is not to believe everything or dismiss everything. The goal is to separate the evidence from the emotional pull of the story. The Cuban formations deserve to be examined as formations first. What are they made of? How are they arranged? What geological setting are they in? Are there artifacts? Are there tool marks? Are there repeated construction features? Do they fit natural processes? Only after those questions are answered should larger historical claims be made. Atlantis also has a way of making a mystery seem older than it needs to be. The moment people invoke Atlantis, the timescale often slides backward into deep prehistory. Claims begin to involve civilizations thousands or even tens of thousands of years older than accepted archaeological evidence supports. That creates another problem. A very ancient advanced civilization would not be expected to leave only one ambiguous deep water sonar site. Civilizations leave traces. Tools, settlements, waste, quarry sites, burial practices, food remains, changes to landscapes, trade materials, genetic signals, and many small pieces of evidence that survive in scattered ways. A city is not a single object. It is part of a network. If a large civilization existed, especially one capable of building monumental stone structures, archaeologists would expect more than one hard-to-read underwater anomaly. That is not because archaeologists are stubbornly attached to old timelines. Archaeology changes when evidence changes. New discoveries can and do revise the past, but revisions come from evidence that can be tested. A tool in a dated layer, a settlement with clear materials, a structure with construction methods, human remains with context, charcoal that can be dated, sediments that tell a consistent environmental story. The accepted picture of the past is not a locked door. It is more like a very heavy door that opens when enough evidence pushes on it. A sonar image alone is not enough weight. The Atlantis temptation also creates a strange emotional trap. If the formations turn out to be natural, some people feel disappointed, as if the ocean has failed to provide a proper mystery. But natural does not mean ordinary. A deep formation that looks like a ruined city would still be remarkable. It would still deserve attention. It would still tell us something about the seafloor, local geology, and the limits of remote sensing. The only thing it would not give us is a vanished civilization. That is a loss only if we decide beforehand that geology is not interesting, which seems unfair to a planet that has spent billions of years making mountains, basins, volcanoes, reefs, caves, cliffs, and the occasional rock that looks suspiciously like a sleeping animal. There is something almost tender about the way people keep searching for Atlantis. Beneath the dramatic claims and wild theories, there is often a simple feeling, the hope that something has been lost and can still be found, a place, a people, a missing part of the human story. Atlantis represents the possibility that the past is not fully gone, only hidden. That is a powerful idea. It speaks to grief, curiosity, imagination, and our discomfort with time. We do not like that whole worlds can vanish. We want the sea to give them back. The Cuban formations, because they are deep and strange and unresolved, become a screen for that hope. People look at them and see what they are already prepared to see. Some see an ancient city. Some see a geological formation. Some see a scientific puzzle. Some see evidence of suppressed history. Some see a headline that grew too large for its facts. The formations themselves do not change, only the stories placed on top of them do. Down there in the dark, the stones, if they are stones, do not know they have been accused of being Atlantis. They are simply there. That is a useful thought. The seabed has no opinion about our theories. It does not become more artificial because we want it to be. It does not become less interesting because skeptics raise objections. It remains what it is. Our job, if we want to understand it, is to bring better methods, not louder certainty. Atlantis may be the word that draws people close, but science has to do the harder work once they arrive. So when Atlantis enters this story, perhaps we should offer it a chair, but not hand it the keys. Let it sit there as part of the cultural background. Let it remind us why humans are so drawn to drowned worlds. Let it explain why sonar shapes beneath Cuba became famous, but do not let it decide the answer before the evidence is spoken. That would be like inviting a guest to dinner and allowing them to rearrange the whole house, because they once told an exciting story about a palace. The formations near Cuba may never have had streets. They may never have held buildings. They may never have known people at all. Or if future evidence surprises everyone, they may force a serious rethinking of what happened in that part of the Caribbean. The honest position is to keep both imagination and caution in the same room, preferably seated apart so they do not start arguing over the biscuits. Imagination keeps the story alive. Caution keeps it from floating away. And maybe that is the real Atlantis temptation. Not simply the temptation to believe in a lost island, but the temptation to let a beautiful story outrun a difficult question. The Cuban underwater formations ask for patient investigation. Atlantis offers instant meaning. Patient investigation is slower, less dramatic, and far less likely to appear on a poster. But it is also the only path that can tell us what is actually down there. So we leave Atlantis where it belongs for now, not dismissed, not crowned, but placed carefully to the side. The next step is quieter, less legendary, more practical. It belongs not to philosophers, treasure hunters, or dreamers of sunken kingdoms, but to geologists, archaeologists, oceanographers, and sonar specialists. Because once the myths have had their turn, someone still has to look at the data, examine the depth, consider the rocks, and ask the plainest question of all: what does the evidence actually support? Once the word Atlantis has had its turn, and once the imagination has been allowed to wander a little around drowned plazas, silent towers, and all the other things it tends to bring along when someone mentions strange stones beneath the sea, the story has to come back to the people whose job is to be careful. Not because careful people are less curious. Usually they are curious in a deeper and more stubborn way. They simply know how easily a mystery can become a conclusion if no one keeps hold of the evidence. So, what do scientists think the Cuban underwater formations might be? The most honest answer is that scientists do not all stand in one neat line pointing at a sign that says solved. The case has not been studied enough, publicly and directly, for that. There has been too little follow-up, too little sampling, too little open data, and too little direct examination of the full site. But the cautious view, the one most consistent with the known problems of depth, geology, and remote sensing, is that the formations are probably natural. Strange, yes. Worth investigating, yes. A confirmed lost city, no. Not with the evidence available so far. That may sound a little plain after all the talk of sunken worlds, but plain is not the same as empty. A natural explanation can still be fascinating. It simply changes the kind of fascination. Instead of asking who built it, scientists ask what forces shaped it. Instead of looking for streets and plazas, they look for faults, fractures, sediment, slopes, rock type, and the way sound might have turned rough terrain into something that looked orderly on a screen. The mystery does not disappear. It changes clothes. It takes off the explorer's hat and puts on a geologist's field cap, which is less dramatic but often more useful. One of the first scientific problems is the depth. The reported site is often described as lying around 600 to 750 metres below the surface. That is not a small detail tucked quietly at the edge of the story. It is the large, stubborn fact sitting in the middle of the room, politely blocking the doorway. If the formations were once built on dry land and later drowned by rising seas, then the sea would have needed to rise by hundreds of metres more than it actually did after the last ice age. That does not match the normal post-glacial sea level story. Many real submerged archaeological sites exist because seas rose after ice sheets melted, but those sites tend to fit within the range of known sea level change. The Cuban formations, if the reported depth is accurate, sit far below that range. This is why geologists and archaeologists become cautious. A shallow underwater settlement can make sense. A settlement in 10, 20, 50, or even around 100 metres of water can often be discussed in relation to changing coastlines, local subsidence, or ancient shorelines. But 600 metres asks for something much more dramatic. It asks for land to have been far lower, or to have sunk enormously, or for some major geological movement to have carried a once dry place downward. And if that happened, scientists would expect evidence of the process. They would want to see how, when, and why it occurred. A city cannot simply be dropped into deep water by a convenient explanation that appears only when the story needs it. Geology is not a stagehand moving scenery between acts. Manuel Iturralde, a Cuban geologist who examined the evidence, did not simply wave the story away. That is important. He reportedly described the site as strange and unusual, and he wanted more evidence before anyone drew firm conclusions. But he also pointed out the problem of time. If something artificial had really sunk to that depth through tectonic movement, the time required would push the supposed construction far back into a period that does not fit known human architectural history in the Americas. That is not a tiny inconvenience. That is a whole cupboard full of inconveniences, and one of the doors will not close. Underwater archaeology expert Michael Fort has also been quoted expressing skepticism about the time frame. The basic problem is simple. If the site had to be extremely old to account for the depth, then it would be far older than the kind of complex stone architecture proposed by the city interpretation. That does not mean human history is fully known in every detail. It is not. New discoveries can change what we think, but a large, planned, monumental city at that depth would not be a small revision. It would require major supporting evidence from many directions. A few sonar shapes cannot carry that weight by themselves. Then there is the sonar problem. Scientists who work with ocean mapping know that sonar is powerful, but not final. Side-scan sonar can show the seafloor in striking detail, but it creates images through sound returns. Hard-raised objects can produce strong echoes. Shadows and soft areas can return weaker signals. Multi-beam sonar can measure seafloor depth by timing how long sound takes to leave the instrument, hit the bottom, and return. These tools are excellent for finding features, mapping terrain, and guiding further exploration, but the images need interpretation. NOAA's explanations of sonar make clear that the picture is made from sound behaviour, not from ordinary vision. That means a sonar image can show an anomaly without identifying its origin. It can say, there is a raised object here, or this surface is hard, or this area has a pattern. But it cannot always say, this is a wall built by people, or this is a natural fracture, or this is a block that fell from a slope. For that, scientists need closer inspection. They need video, photographs, samples, context, repeated mapping, and preferably several experts who disagree politely until the evidence makes one explanation stronger than the others. Science is often a long conversation between people who all want to be right, but, at their best, want the evidence to be right even more. One possibility scientists consider is that the formations are a natural rock structure shaped by fractures. Rock often breaks along joints, bedding planes, or faults. These breaks can create straight lines, blocks, and repeated angles. To a sonar system, especially from a particular direction, those lines may look like walls or streets. If the rock is layered, some layers may erode more than others, leaving steps or terraces. If blocks have separated from a larger outcrop, they may sit like pieces of masonry. If sediment fills the gaps between them, the result may look even more like a built surface. None of this requires people. It requires rock, stress, water, gravity, and time, which are all available in generous amounts and rarely ask for credit. Another possibility is that the site is connected to underwater slope failure or landslide debris. Deep-sea slopes can collapse, large blocks can break loose and settle lower down. These blocks may be angular, repeated, and partly buried. In a sonar image, they can seem arranged, especially if they originated from the same rock layer and broke into similar pieces. A field of landslide blocks can look like ruins from a distance. It can have the feeling of a shattered structure, even when the structure was only a natural slope that gave way. The ocean floor has its own rubble, and not all rubble is archaeology. Scientists may also think about sedimentary or carbonate processes. Around tropical regions, carbonate rocks and limestone can form, dissolve, fracture and erode in unusual ways. Limestone, especially, can create blocky surfaces when water widens cracks and joints. On land, limestone pavements can look almost artificial, with flat slabs divided by grooves. Underwater, a similar kind of blocky terrain could become even harder to read. If sonar shadows stretch behind the raised pieces, the blocks may appear taller. If sediment lies in the cracks, the flat parts may look like separate stones placed in a pattern. It is not hard to see how a natural surface could begin to resemble foundations. There is also the possibility of volcanic or igneous material. Early reporting mentioned recovered volcanic rocks, and the difficulty of explaining them in that setting, since Cuba is not known for active volcanoes in the way some other Caribbean islands are. But even an unusual rock type does not automatically mean human construction. Rocks can be transported, exposed, displaced, or misidentified. Ancient geological history can put materials in places where a simple, modern map would not expect them. A rock that looks out of place is interesting. It is not automatically a building block from a lost city. It is a clue, and clues need other clues around them before they become a story. A more cautious explanation is that some of what people are seeing may be imaging effect rather than physical architecture. This does not mean the sonar was wrong, or that the people who first saw the data invented something. It means the way sonar forms images can emphasize shapes, shadows, and contrast. A rough, natural terrain can look more regular if the resolution is low enough to smooth details but high enough to show broad forms. A ridge can look like a wall, a depression can look like a road, a shadow can look like an opening, a cluster of outcrops can look like arranged blocks. Anyone who has looked at a coat hanging in a dark room and briefly believed it was a person understands how incomplete information invites the mind to help, sometimes too much. This is why some scientists, including Sylvia Earle, have taken the position that the site should be checked, but that a natural origin should be assumed until evidence proves otherwise. That is not a dismissal. It is a method. In science, the simplest explanation that fits the evidence usually gets tested first. If natural geology can explain the shapes, then geology is the leading explanation. If geology fails and if artificial features are documented, then the human-made explanation becomes stronger. But the burden of proof sits with the extraordinary claim: a deep underwater city would be extraordinary, so it needs more than resemblance. It needs material proof. What would count as stronger proof? Clear tool marks would matter. Stones cut in ways that could not be produced by natural fracture would matter. Repeated architectural units would matter. Mortar, carvings, pottery, worked tools, human remains, food debris, or datable cultural material would matter. A pattern of construction that continues across the site and makes sense as human use would matter. Samples showing that blocks were transported from somewhere else would matter. Sediment layers showing when the site was exposed and when it was submerged would matter. These are the kinds of things scientists would look for before calling it a city. Notice how different that is from saying, "It looks like a city." Looking like something is the beginning of a question. Being that thing requires evidence. A cloud can look like a rabbit. A rock can look like a face. A mountain ridge can look like a wall. A natural arch can look like an entrance. A shadow can look like a doorway. The world is full of lookalikes. Some are amusing. Some are misleading. Some are important enough to investigate. The Cuban formations belong in that last category, at least from the point of view of curiosity. They're interesting enough to ask about, but they are not proven enough to name. Scientists also have to consider the wider archaeological record. If a large stone-built urban centre existed in the Caribbean or near Cuba, at a time old enough to account for the depth, it would not exist in isolation. A city requires people, food systems, tools, building knowledge, social organisation, and connections to a surrounding landscape. Archaeologists would expect traces elsewhere: camps, quarries, smaller settlements, tools, shell middens, agriculture, burial sites, or other evidence. A whole civilization does not usually leave one ambiguous deep water formation and nothing else. Human societies leave mess. That is one of our most reliable traits. We drop things, break things, burn things, sharpen things, bury things, trade things, and lose things under beds. Archaeologists are very grateful for this. That does not mean the record is complete. Far from it. Many ancient coastal sites are now underwater. Tropical environments can destroy organic remains quickly. Erosion, storms, reefs, and sea level change can hide or damage evidence. But a claim of very ancient advanced architecture still needs supporting context. Without it, scientists are left with a site that looks odd, but does not fit the broader picture. And when a piece does not fit, there are two possibilities. The puzzle is missing many pieces, or the piece belongs to a different puzzle. At the moment, many scientists suspect the Cuban formations belong more to geology than archaeology. There is also a practical reason scientists may not speak about the site as much as the public expects. There may simply not be enough new evidence. Science does not thrive on repeating the same uncertainty over and over. If no major expedition has produced new samples, new maps, or new peer-reviewed analysis, then there is not much for researchers to add. The public sees silence and sometimes imagines secrecy. But often, silence just means no new data. Researchers cannot publish conclusions from evidence they do not have. They cannot sample rocks by wishing at them from the shore. They cannot date a structure without materials to date. The ocean is not withholding answers out of drama. It is withholding them because it is deep, expensive, and inconvenient. Some scientists may think the site deserves another expedition. That position is perfectly reasonable. An unusual deep formation near Cuba, reported with block-like and geometric shapes, could benefit from modern mapping tools. High-resolution multi-beam sonar, improved side-scan systems, remotely operated vehicles, precise navigation, photogrammetry, and sampling tools could provide far better evidence than early surveys. A new expedition might show clear natural geology. It might reveal something stranger. Either way, it would reduce the uncertainty. The problem is not that scientists are uninterested in mysteries. The problem is that mysteries in deep water require money, equipment, permissions, and priorities. If a modern team went back, they would probably not begin by saying, "Let us prove or disprove Atlantis." They would likely begin with a survey plan. Map the area, establish coordinates, measure the formations, build a detailed bathymetric model, compare the shapes with regional faults and slopes, use an ROV to film the features from multiple angles, take samples from blocks, nearby bedrock, and sediment. Look for layering, fractures, tool marks, and biological growth. Analyze the rocks in a lab. Date sediments if possible. Search for cultural material, but do not assume it will be there. In other words, they would treat the site as a scientific problem, not a legend that needs a dramatic ending. That kind of investigation might sound slow, but slow is what keeps the answer useful. The early excitement around the Cuban formations came partly because the images were unusual. But unusual images are not enough. Scientists know that if they call something a city too early, and it later turns out to be fractured rock, trust is damaged. Better to be careful. Better to say, "This is strange," than to say, "This rewrites history," before the samples are even dry. Or in this case, before they are even collected. There is also a middle possibility that should not be ignored. The site might be natural, but still visually remarkable. It might be an unusual geological formation that deserves study in its own right. It might show processes not well documented in that region. It might include features shaped by a combination of tectonics, carbonate geology, sediment movement, and sonar effects. It might be rare. It might be beautiful. It might even be the kind of place that, if photographed clearly, would become famous as a natural wonder rather than a lost city. That would not be a failure. It would be a different success. A natural explanation can still give us a good story because Earth is not short on strange construction. It makes columns from cooling lava, caves from dissolving limestone, arches from erosion, terraces from sediment, and polygonal cracks from drying mud or cooling rock. It folds mountains, opens basins, drops cliffs, and builds reefs from countless tiny animals over long periods. Compared with that, making a patch of seafloor that looks a little like ruins is well within nature's skill set. Nature may not build cities, but it can make very convincing stage sets. The scientist's caution, then, is not a refusal to wonder. It is a way of protecting wonder from exaggeration. If the formations are natural, they are still part of the hidden world beneath the Caribbean. If they are artificial, they would be one of the most important archaeological discoveries ever made. Those two possibilities are not equal in probability, but both depend on evidence. Until better evidence arrives, the scientific answer remains careful. Probably natural, definitely interesting, not proven as a city. And perhaps that is where this part of the story settles for now, not in certainty, but in method. The sonar showed something unusual. The depth made the city idea difficult. The geology offers possible explanations. The archaeology lacks supporting evidence. The ocean has not been examined enough to close the case. Scientists look at all of that and resist the urge to leap. It is a very human urge, leaping. We leap from shape to structure, from structure to city, from city to civilization, from civilization to Atlantis, and before long we are packing for an expedition with more confidence than data. Science asks us to walk instead, slowly, with notes, and ideally with a rock sample, so the Cuban underwater formations remain in a careful category. They are not dismissed as nonsense because unusual seafloor features can be real and important. They are not accepted as ruins because the evidence does not yet support that. They are a question waiting for better tools, better access, and a more complete investigation. The formations may turn out to be blocks made by faults, terraces made by erosion, debris from an old collapse, or a sonar image that made natural terrain seem more organised than it was. Or, if the ocean is feeling especially mischievous, they may contain something that surprises everyone. For now, scientists do what good scientists often do. They keep the door open, but not wide enough for every theory to wander in wearing muddy boots. They ask for samples, they ask for maps, they ask for context, they ask for dates, they ask for proof, and down below, beyond the bright water, the formations wait without answering. The longer they wait, the more another part of the story begins to matter. Not just what the formations are, but why the ocean is so good at keeping such questions alive. Because the sea does not only hide objects, it hides scale, distance, evidence, and time. It can turn a simple shape into a global mystery, and it can keep that mystery suspended for decades, not because it is trying to deceive us, but because deep water is one of the hardest places on Earth to ask a question clearly. The ocean is very good at making simple questions difficult. On land, if someone says there is a strange stone shape in a field, you can usually go there, walk around it, take photographs, touch the surface, measure it, and decide whether it is a wall, a boulder, a broken foundation, or something a farmer has been meaning to move since 1987. Land does not always make archaeology easy, but it allows people to stand near the evidence. You can dig, you can scrape, you can compare soil layers, you can argue beside the trench while someone holds a clipboard and pretends the weather is fine. The deep ocean does not allow that kind of direct conversation. At hundreds of meters below the surface, the Cuban underwater formations sit in a place where ordinary investigation becomes slow, expensive, and highly dependent on machines. This is one of the main reasons the story has remained alive for so long. It is not just that the formations were strange. It is that they were strange in a place that does not allow easy checking. a mystery on a beach might last a day. A mystery in deep water can last decades, not because the answer is necessarily extraordinary, but because getting the answer requires ships, equipment, permissions, specialists, and enough funding to make everyone involved check the budget twice. Think for a moment about what it would mean to properly investigate the site. A research vessel would need to reach the area. The team would need precise coordinates, and not just a general somewhere over there beneath the blue bit. They would need modern sonar to map the full region again, ideally from several directions and at high resolution. They would need a remotely operated vehicle, often called an ROV, lowered from the ship on a long tether. That tether would carry commands down and data back up. The ROV would need lights, cameras, navigation systems, perhaps mechanical arms, and enough stability to move slowly over the seabed without stirring up sediment or bumping into the very thing everyone came to study. Then the operators would need to guide it across the formations, record video, take measurements, place scale references, collect samples if possible, and keep track of location in a dark environment where there are no street signs, no landmarks in the ordinary human sense, and absolutely no helpful person leaning out of a window saying, "You want the ancient ruins? Third block on the left." That is the practical reality behind the mystery. It is not enough to say, someone should go look. Of course someone should go look. That is the obvious part. The difficult part is that looking, in this case, is a technical operation. It is a ship-based deep-sea survey, not a curious afternoon stroll. The ocean keeps its secrets well because it makes every answer cost effort. There is also a problem of scale. The reported formations cover an area large enough that a single camera pass would not settle much. A remotely operated vehicle can show a close view, but close views are narrow. You might see a surface that looks flat. You might see an edge. You might see a block. But without the wider map, you may not know whether that block is part of a natural ridge, part of a landslide field, part of bedrock, or part of a pattern that continues in a meaningful way. Close images can be convincing and misleading at the same time. It is rather like looking at one brick and trying to decide whether you're standing in a wall, a chimney, a garden path, or the remains of someone's ambitious but unfinished pizza oven. This is why full mapping matters. High-resolution bathymetry would show the shape of the seafloor in detail. Side-scan sonar would show texture and acoustic shadows. Video would show surfaces and context. Samples would show what the material actually is. Each kind of evidence fills a different gap. Without all of them, people are left with fragments, and fragments are where stories grow. The ocean also keeps secrets through darkness. In shallow tropical water, sunlight can turn the seafloor into a bright, readable place. Divers can see colour, distance, motion, and texture. At the reported depth of the Cuban formations, sunlight is gone. Artificial lights become the only way to see, but artificial lights in deep water create their own problems. They illuminate only a small area at a time. They create strong shadows. They flatten some details and exaggerate others. Particles in the water can reflect light back into the camera, making the view hazy. Sediment stirred up by a vehicle can hang in the water like smoke in a quiet room. A surface that looks sharp in one frame may look ordinary in another. A crack may look like a carved line. A ledge may look like a step. A natural block may look placed. None of this means deep-sea video is useless. Far from it. It can be extremely valuable, but it has to be read carefully, especially when people are already hoping to see ruins. If the mind arrives first with a city in mind, then every light beam becomes an invitation. A straight edge becomes a wall. A gap becomes a street. A shadow becomes an entrance. The camera records what is there, but the viewer may add what is expected. The ocean does not need to lie. It only needs to be hard to see. Pressure is another part of the problem. At deep water depths, pressure is not just a dramatic detail. It affects equipment design, operations, and risk. Instruments have to survive the environment. Housings must be sealed. Cables must handle strain. Mechanical parts must work in cold, dark water under heavy pressure. A small failure can end a dive. A tangled tether, a damaged thruster, a lost tool, a navigation error, or bad weather at the surface can interrupt the whole operation. The mystery may be on the seabed, but the work depends on everything from sea conditions to engineering. Even the most patient scientist cannot collect a rock sample if the ship cannot safely hold position, or the ROV has decided that today is a fine day to develop a technical issue. Then there is the question of location. Deep-sea work requires returning to the same place accurately. That might sound simple in an age when phones can guide us to a coffee shop, but underwater navigation is different. GPS signals do not travel through seawater in the way they do through air. The ship knows where it is at the surface, but the vehicle below must be tracked by acoustic systems, inertial navigation, cable length, and careful positioning. In deep water, a small error at the surface can matter. If the formations cover a large area, the team must build a careful map, then match the vehicle's path to that map. Otherwise, the investigation becomes a very expensive version of searching for your keys while the room is completely dark and the floor keeps moving. The seafloor itself can also hide what matters. Sediment may cover parts of the formations. Currents may expose some surfaces and bury others. Biological growth may coat rock, making natural and artificial surfaces harder to distinguish. Chemical processes may alter exposed stone. A feature that once had a clear edge may now be softened. A crack may be filled. A block may be partly buried. If there were artifacts, they might be scattered, covered, damaged, or absent from the areas first examined. If the site is natural, sediment can still make it look more like a set of placed stones by hiding the connections between blocks and bedrock. The ocean is very skilled at editing the scene. It does not remove everything. It removes just enough to keep people arguing. This is one reason why underwater archaeology, especially in deep water, is so different from land archaeology. On land, the surrounding context can often be studied layer by layer. Underwater, context may be disturbed by currents, storms, slope movement, organisms, and sediment transport. Objects can move, surfaces can be buried, a shipwreck can scatter across a seabed, a submerged landscape can be eroded. A natural formation can be partly covered in ways that make it appear artificial. The evidence is not only hard to reach, it may also have been changed by the environment. The Cuban formations are especially difficult because the public story has long been larger than the public evidence. Many people know the headline, fewer people know the data. That imbalance allows the mystery to remain flexible. When evidence is limited, people can lean the story in the direction they prefer. A believer can say the lack of follow-up is suspicious. A skeptic can say the lack of evidence is telling. A cautious researcher can say both positions are getting ahead of the data. The ocean, meanwhile, continues doing absolutely nothing to clear up the misunderstanding, which is very much its style. It is useful to remember how little of the seafloor has been mapped in modern high-resolution. NOAAs. April 2026 figure of 28.7% is much better than it was decades ago, but it still means most of the global seafloor has not been mapped at that standard. That does not mean we know nothing about the ocean floor. We have broad maps, satellite-derived estimates, ship tracks, and many detailed surveys in important regions, but detailed, modern mapping is uneven. Some areas are well studied, others are known only in broad shape. The ocean is not a blank space, but it is not a fully read book either. It is more like a huge library where many shelves have labels, some books have been opened, and many pages are still stuck together. That matters because people sometimes expect every major underwater feature to already be known. The truth is that new seafloor features are still being mapped. Deep reefs, vents, wrecks, landslides, channels, and unusual habitats can remain poorly documented for a long time. Not because anyone is hiding them, but because the ocean is vast and detailed surveying takes time. A deep formation near Cuba can remain uncertain simply because there are more questions beneath the sea than there are ships available to answer them. The ocean also keeps secrets by making priorities compete. A research ship can only be in one place at a time. Scientists may need to study climate records, deep sea ecosystems, hazards, fisheries, coral habitats, submarine landslides, plate boundaries, pollution, or conservation areas. A mysterious formation that might be natural has to compete with all of that. Public curiosity is powerful, but funding usually asks harder questions. What will the expedition prove? Who will support it? What permits are required? What equipment is available? What scientific value can be guaranteed? The answer, people on the internet would really like to know, is emotionally strong but not always enough to book a vessel. Politics and jurisdiction can add to this. The formations were reported in waters associated with Cuba, so access depends on cooperation, legal permission, and institutional arrangements. Marine research is not carried out in a vacuum. It involves national waters, heritage laws, environmental rules, sometimes security concerns, and the practical work of international collaboration. Even when a site is interesting, the process of returning to it can be slow, and slow processes are fertile ground for speculation. When people do not see an immediate answer, they often imagine a hidden reason. Sometimes there is a hidden reason. More often, the reason is paperwork, money, equipment schedules, and the quiet exhaustion of everyone who has ever tried to organise a complex field project. There is another way the ocean keeps secrets. It protects ambiguity. On land, ambiguity is often temporary. You can return tomorrow with a shovel, a camera, a specialist, and a packed lunch. Underwater, especially in deep water, ambiguity can remain the default condition. A sonar image can be suggestive but not conclusive. A video clip can be interesting but not complete. A sample can answer one question but raise another. A survey can map an area but still not reveal whether shapes are natural or artificial without direct context. The ocean allows partial knowledge to linger. It gives a little, then stops. That is why the Cuban formations are not only a story about possible ruins. They are a story about the limits of access. They show how the unknown survives in a technological age. We live with satellites, maps, high-speed data, and devices that can tell us the nearest restaurant in seconds. It is easy to feel that the world has been fully inspected, but deep water pushes back against that feeling. It reminds us that there are still places where a single question may require an expedition, and an expedition may still return with an answer that begins. It appears that there is something healthy about that. Not every mystery needs to be solved quickly to be valuable. Some mysteries teach patience. They make us notice how evidence is gathered. They make us separate strong claims from careful work. They remind us that not knowing is not the same as being deceived. It is simply the normal state before enough information has been collected. The ocean does not owe us instant clarity. It has never agreed to become a search engine, and frankly it would probably ignore the terms and conditions. Still, the secrecy of the ocean can be frustrating. The Cuban formations have been discussed for years, and yet the public still lacks a final, widely accepted answer. Are they fractured rocks, landslide blocks, limestone features, sonar artifacts, a natural geological formation made dramatic by shadows, something else? A clear modern survey could narrow those possibilities. Samples could help, full data could help, independent analysis could help. But until those things happen, the formations remain in that quiet category of unresolved deep-sea anomalies. And unresolved does not mean equal possibilities. It does not mean every explanation has the same chance. The natural explanations remain stronger because they fit the depth problem and the known behaviour of rocks, sonar, and the seabed. A lost city remains a far more demanding claim. But unresolved means the exact identity of the formations has not been publicly pinned down in the way a careful investigator would prefer. It means the shapes are not fully explained in public evidence. That is enough to keep the story alive, but not enough to crown it as archaeology. The ocean often gives us this kind of half-lit evidence. A wreck appears as a shadow before it becomes a ship. A reef appears as roughness before it becomes an ecosystem. A vent field appears as a chemical signal before cameras show the animals living around it. A geological structure appears as a strange line before mapping reveals its form. Discovery often begins with something unclear. The mistake is not being intrigued by the unclear thing. The mistake is deciding too soon what it must be. For the Cuban formations, the best future would not be a louder argument. It would be a quieter, better survey. A ship returning with modern equipment, a careful grid over the area, multiple sonar passes, a detailed map, ROV dives with clear scale markers, rock samples from several points, sediment cores if possible, analysis by geologists and archaeologists who are not trying to force a conclusion, public release of enough data for independent review. That would not guarantee a spectacular answer, but it would give the mystery what it has needed all along: less fog. Until then, the ocean keeps the advantage. It holds the formations in darkness, pressure, distance, and salt water. It lets sonar touch them from above, but only through sound. It lets cameras see small pieces, but not easily the whole. It lets us name possibilities, but not confirm them without work. It keeps the site suspended between geology and legend, between data and imagination, between the seafloor as it is and the seafloor as we hope it might be. That may be why the story fits so well into a quiet night. It is not a mystery that rushes. It does not chase us. It waits. It sits below the Caribbean, whether as natural stone, unusual terrain, or something not yet fully understood. Above it, the waves move as they always have. Boats pass, weather changes, light comes and goes across the surface. Far below, the formations remain beyond easy reach, not hidden behind a locked door exactly, but behind the larger lock of the ocean itself. And perhaps that is enough for now. Not enough as an answer, but enough as a reason to keep looking carefully. The sea has kept shipwrecks, fossils, ancient coastlines, lost cargo, deep reefs, strange animals, and geological records for longer than any archive on land. It has also kept many ordinary rocks that people briefly mistook for something else. The task is to learn which kind of secret this is. A human one, a geological one, or simply a lesson in how easily the unknown can take the shape of our expectations. So we remain above the mystery for a moment longer, looking down through water we cannot see through, towards shapes we cannot yet name with confidence. The story has brought us from sonar screens to sea level problems, from natural stone patterns to the pull of Atlantis, from scientific caution to the practical difficulty of deep exploration. And now it begins to narrow into something quieter. Not a final verdict, not a grand revelation, but a return to the human feeling that started it all. The strange comfort of knowing that the world is still not completely explained. And now we drift above the mystery again, not with a firm answer in our hands, but with a clearer sense of why the answer has stayed out of reach. The story began with shapes beneath the water, seen through sound, far from easy inspection, in a place where the sea is deep enough to turn curiosity into a full expedition. It is tempting to want a clean ending, a label, a verdict, a sentence that says, the formations are this, or the formations are that. But the Cuban underwater formations do not give us that kind of ending, at least not yet. They remain in the difficult space between strange evidence and strong proof, and that space can be frustrating if we're hoping for certainty. It can also be useful, because it teaches us how mysteries really work when they are not dressed up for a headline. A headline can be quick, a sonar image can be exciting. A phrase like underwater city can travel around the world before anyone has finished checking the depth, the geology, the survey details, or the meaning of the shadows on the screen. But the seafloor does not move at the speed of headlines. It waits under pressure and darkness. It does not explain itself because someone has given it an interesting name. It does not become a city because people want one. It does not become ordinary rock because skeptics are tired of speculation. It remains exactly what it is, whatever that may be, and the only way to know more is to go back with better tools, better maps, better samples, and a willingness to accept an answer that may be less dramatic than the question. That is one of the quieter lessons of this whole story. Wonder is easy to start. Evidence is harder to gather. The first comes from a moment of surprise, from seeing a pattern where none was expected, from noticing something that seems to interrupt the normal shape of the world. The second comes from repetition, testing, measurements, arguments, correction, and often a great deal of paperwork. Wonder opens the door. Evidence tells us whether there is actually a room on the other side, or just a shadow that looked like one in poor lighting. The formations beneath Cuba ask us to hold two ideas at once. The first is that the world still contains things we do not fully understand. That is true. The ocean is vast, difficult to study, and still unevenly mapped in detail. New features are found, old assumptions are revised. Strange landscapes wait below the surface. Shipwrecks remain undiscovered. Ancient coastlines lie buried or submerged. Deep habitats exist where no one expected much life at all. The planet is not finished revealing itself, which is a comforting thought, especially in a time when so much information seems to arrive instantly on a screen. The second idea is just as important. Not every unknown is a lost civilization. Not every straight line is a wall. Not every block is a building stone. Not every pattern has a human hand behind it. Nature has had billions of years to practice making shapes that surprise us. It can crack rock into blocks, carve limestone into pavements, shift slopes into piles of angular debris, and turn the seafloor into a place that looks organised without ever being planned. The hard part is not choosing the exciting answer or the boring answer. The hard part is allowing the evidence to decide which answer is best. And perhaps that is why this mystery has such a hold on people. It sits right at the meeting point of imagination and caution. If we lean too far into imagination, we may start seeing streets, temples, and ancient people where there are only fractured rocks. If we lean too far into dismissal, we may stop looking at unusual evidence too soon. The better position is somewhere between those extremes. Not believing everything, not mocking everything, just looking carefully and being honest about what is known, what is guessed, and what has not yet been shown. The reported depth remains one of the strongest reasons for caution. A site hundreds of meters below the surface cannot be explained by ordinary sea level rise after the last ice age. That does not mean the formations are uninteresting. It means the lost city idea has a heavy burden to carry. To support it, one would need evidence of artificial construction, a believable explanation for how the site reached that depth, and a wider archaeological context that fits with what is known about human history in the region. Without those things, the simplest explanation remains natural geology, perhaps made more mysterious by sonar shadows, limited data, and the very human habit of seeing pattern in partial information. Still, natural does not mean dull. If the formations are natural, they may still be remarkable. They may tell a story about the Cuban margin, about old rock movement, about underwater slopes, sediment, erosion, or fracture patterns. They may show how deep-sea terrain can imitate architecture from a distance. They may become a useful example of how sonar can reveal and confuse at the same time. A natural answer would not make the story worthless. It would simply move the wonder from lost people to the planet itself. And the planet is not a small subject. Imagine for a moment that a future expedition finally returns to the site. A research vessel moves slowly over the water west of Cuba. The crew lowers new equipment into the sea. The sonar maps the formations in finer detail than before. A remotely operated vehicle descends through the dark, its lights switching on as it nears the seabed. Cameras move across the shapes that have carried so many stories. Scale markers appear beside the blocks. Samples are collected. The vehicle turns, hovers, moves closer, backs away, and the team begins to see whether those edges are cut or fractured, whether those surfaces are separate stones or bedrock, whether the patterns continue naturally across the slope, or whether something truly unusual is waiting there. That future survey might end the city story. It might show a field of natural rock. Impressive, but not artificial. It might show that the most famous shapes were created by sonar angle, shadows, and fractured geology. There would be disappointment from some, relief from others, and probably a few people who would continue to disagree no matter what the sample said, because that is one of the oldest human traditions. But it would still be progress. A mystery replaced by knowledge is not a loss. It is a change in lighting. Or, less likely but not impossible in the broad sense of discovery, the survey might find something that demands more attention. Not a ready-made Atlantis, not a complete underwater metropolis waiting politely for a documentary crew, but some feature that cannot be explained easily by geology. A worked surface, transported stone, repeated construction details, cultural material, something with context, something that can be tested. If that ever happened, the conversation would change. Scientists would not ignore clear evidence of human work simply because it was inconvenient. They would argue, test, publish, challenge, return, and test again. That is how large discoveries become accepted. Not through one exciting claim, but through evidence strong enough to survive people trying very hard to prove it wrong. For now, we're not there. For now, we're above the mystery, looking down through layers of water, reports, interpretations, doubts, hopes, and old headlines. We have sonar shapes. We have descriptions of geometric patterns. We have the problem of great depth. We have possible natural explanations. We have the cultural pull of Atlantis. We have scientific caution. And we have the ocean itself still making everything slower than we would like. There is something almost comforting about that slowness. Not every story has to be solved before morning. Not every question has to be turned into a clean answer the moment it appears. Some questions are better treated as places to rest the mind for a while. The Cuban formations give us that kind of place. They let us think about how little of the deep sea we have seen directly. They let us think about how evidence changes when it passes through machines before reaching our eyes. They let us think about the difference between resemblance and proof. They let us think about how easily a name can shape a story. Call something a rock formation, and people move on. Call it a city, and suddenly the whole world wants a map. Maybe that is one reason the story keeps returning. It's not only about what lies under the water. It is about what lies inside us when we hear about it. The desire for hidden history. The wish that the past still has surprises. The hope that there are places no one has explained yet. The fear that everything has already been measured. The pleasure of finding out that it has not. A strange sonar image beneath Cuba touches all of those feelings at once, and so it becomes more than a seafloor feature. It becomes a small reminder that certainty is not evenly spread across the world. The surface of the sea can look simple from above. Blue water, sunlight, waves, a boat passing in the distance, birds moving over the coast. But beneath that surface are slopes, basins, ridges, wrecks, reefs, channels and dark plains. There are places humans have never visited. There are places we have mapped only roughly. There are places where sound has touched the bottom, but no camera has lingered long enough to explain it. The Cuban formations belong to that hidden geography. Whether they are natural or artificial, ordinary or unusual, they are part of the enormous underwater landscape that surrounds every continent and island on Earth. And perhaps that should make us a little humble. We are very good at naming things. We name seas, islands, currents, trenches, peninsulas, reefs, formations and mysteries. But naming is not the same as knowing. The phrase Cuban underwater city is a name shaped by excitement. The phrase Cuban underwater formations is more careful. Neither phrase is the thing itself. The thing itself is still down there, under the water, waiting for better evidence to speak on its behalf. So, as this quiet journey comes toward its close, we do not need to force the formations into one answer. We can leave them where they honestly are, strange enough to remember, too deep for easy explanation, too poorly documented for grand claims, most likely natural, based on what is known. Still worthy of curiosity because unanswered questions have their own value when they are handled carefully. And maybe tonight, that is the best place to rest. Not in a dramatic revelation, but in a calmer kind of understanding. The world is not divided neatly into the known and the impossible. There is a large middle area filled with things that are partly seen, partly measured, partly misunderstood, and still waiting for the right tools. The formations beneath Cuba sit in that middle area. They remind us that mystery does not always mean magic. Sometimes it means distance. Sometimes it means cost. Sometimes it means the data is incomplete. Sometimes it means the ocean is deep and the boat has not gone back yet. If you have stayed with this story all the way down and all the way back up again, then you have travelled through more than a rumour about a sunken city. You have moved through sonar and shadow, sea levels and stone, geology and old legend, scientific caution and human hope. You have followed a question that began as a pattern on the seafloor and grew into a lesson about how we search for truth when the evidence is far away. That is a gentle kind of exploration, but it is still exploration. And now, wherever you are listening from, let the scene become simple again. Not a headline, not a debate. Just the western edge of Cuba, the dark water beyond it, and far below, a patch of seabed that once made people stop and look twice. Above it, the sea keeps moving. The surface rises and falls. Night settles over the water. The coast is quiet. The instruments are gone. The screens are dark. The formations remain. If this story gave you a little calm, a little curiosity, or just a quiet place to let your thoughts slow down, I would be grateful if you liked the video, subscribed, and stayed with Life Beyond Seen for more soft journeys into science, history, strange places, and the parts of the world that still ask patient questions. There will always be more to explore, not because every mystery hides a lost city, but because the real world is already full of hidden rooms, deep water, old stone, and unfinished explanations. Tonight, the Cuban formations do not need to be solved in order to be meaningful. They can remain what they are for now, a strange report from the dark, a reminder of the limits of our maps, and a quiet invitation to keep looking carefully, not with fear, not with wild certainty, just with steady curiosity. So let the mystery stay beneath the waves for a while longer. Let the ocean keep its secret until someone returns with lights, cameras, samples, and patience. Let the unanswered parts settle gently, without needing to become anything more before sleep. The sea has waited a long time. It can wait a little longer. Sleep well, fellow traveller, wherever you are tonight, above whatever quiet depths your own dreams may cross.